In this video, we're going to build a cool little command line utility to talk to the OpenAI that will load our assistant and upload our instruction, our files, and so on. Everything will be configured inside our body2ml, where we have our model, our instruction files, and we even have the file bundles that we can even bundle our source code and some knowledge files. And then with that, we can ask questions like, what is the best language? We'll have the little colors and everything. And that obviously has been seeded in the instruction. And second best, this also has been seeded, obviously. And then we can even ask questions about our code. Say, what is the difference between the IS and body modules? So basically between this one and this module, what is the difference? Be concise. Up. And he would get the answer of this, which is pretty cool, because the IS module is going to be the one responsible to access the OpenAI API with the async OpenAI crate, and the body is kind of an abstraction above managing higher level concepts. Okay, so with that, let's go and let's start from scratch. So the first thing that I like to do now that we have that in our cargo2ml is to have our lints rust. And the first one here is I'm going to forbid any unsafe code, and then I'm going to have the unused allow, and that is just for the early dev. Eventually, I want to remove that because it's actually very good warnings and it allows even some time to find some code. Okay, so for now, we're going to put it like that. So now let's go to the dependencies. We're going to use Tokyo for the async. We're going to use a cool async OpenAI to be able to talk to the OpenAI API. We're going to use 2ML and the CRD JSON with CRD for the serialize and deserialize. And then on the command line side, we're going to use dialogger and console to be able to have nice prints, and text wrap to make sure we can wrap everything. On the files, we're going to use walkdir and globset to be able to walk the directory recursively and to be able to kind of match files. And then last, we're going to use our derive more for our error and other struct to have from and display and derive implementations. Okay, so typically then what I do is I go to my main.rs and I put my terminal up and I'm going to do a cargo run just to make sure that everything works. So now we are going to go there. And one of my best practices is I have for the main modules, and main is obviously a main module, I have a modules section, and that is where I put my module and my re-export. One of the first one and the most important one is the mod error. So we're not going to use anyhow, and we're not going to use this error as well. But what we want at the beginning is something that feels like anyhow, such as we don't put unwrap everywhere, but at the same time, we don't want to define all of the froms and everything because it gets pretty heavy. But we know we want to define all of the from and everything eventually to have robust code. So here's a trick here that I really like. So I have my mod error, because that is what I'm going to have in my production code, in my future code. And in fact, my pattern as well is to re-export the error, so the one that comes from this crate, that will come from this crate, and result, which is a result type alias on this error. So like this, everything is very well normalized, and I cannot have a mess with my error. So that is what I found very well. So now here's a super cool trick. We're going to create the error file, can be a single file. We're going to go to the file. We don't need the command line for now. We're going to export type alias error, which is just going to be our box of DIN standard error. So that is usually what you do when you don't want to worry too much about the errors. You do a return of result of that box. But we're going to do a type alias, and there is a reason for that. Because then what we're going to do on top is just a pub results that. So that will actually stay there, even in my production code, because that is the best practices where we are doing a type alias of t, whatever, on the error of this module, which is this one. So that will be for our beginning, where we'll be able to do question mark everywhere without worrying too much about it. And it even have a from static string and a from string, so it's going to be very easy to do custom errors. And then eventually, what is going to happen is in our final code, we're going to comment this or remove that, and then we're going to have our use derived from, and then we're going to have our clean errors over there. And then we'll even be able to do a custom for strings. So all of the custom strings that we'll have in our code they would still be supported there. And then eventually you want to comment this out, such as everything is tight and not custom. And you can even have a custom from here, str custom. And so with this technique here, we can start just with that, with our error, nothing else. Now our main will compile. So we go back to main. And so now we have this error here where we can return a result of whatever type we want, and then anything can go on the question mark. And the cool thing about this approach is that later, when we're going to crystallize these errors, we just have to change the error files. There's not going to be anything that needs to be changed in the other file, except if we want to customize some of the custom errors. But we can make everything compile with a relatively good structure just by changing our errors.rs. So that is going to be pretty cool. Okay, so now we're ready to have some fun. We're going to create our first lower level module, which is going to be our mod AI services. So AIS. We're going to create the module and we're going to create it as a folder because we're going to have the IST below. And then later, we'll have our application module, which is going to be our application agent. And we're going to call it buddy. We could call it agent as well. So the goal here is that the IIS is going to be the lower level layer to talk to the AI services. Eventually, we could have a provider architecture over there. And then buddy will be our agent, which will be our application-specific entity. So what we're going to do is focus on our AIS module. So we're going to go there, and we're going to make our first calls to the OpenAI API. So first, that is a module, so we're going to follow our best practices. At this point, we're not going to have our own error in this module. Eventually, we could, and then we'll have the error and the result, the matching result, to follow the pattern. But for now, we're going to use our create result. That would be perfect. Then one thing that we're going to do, and that's for later, is we're going to create a submodule, and that will be for assistant. And we're going to make it pub because we want to export that, and then we're going to create a module like that. So now that we have that, at the main root of this module, there's a couple of things we want to do, and we want to create the async OpenAI client. That will be the responsibility of the root module in a way. So a couple of things. First, we're going to have our constant, and that is because we're going to check if the API key is present or not. And then we're going to create a type alias that is really a personal preference. And that is because there's a generic, and so I prefer to have OpenAI client as a type everywhere rather than carrying these two types. But that is really a personal preference. And now that we have that, the first thing that we're going to do is going to be a pub fn new OpenAI client. So I will use the OA for OpenAI and OAC for OpenAI client. And we're going to return our result, and that will be the OA client, which is just the alias of that. We're going to do our to-do, and we press save. Now we're going to import this one here from async OpenAI, and then this OpenAI config from async OpenAI. And so that is because the async OpenAI can talk to the OpenAI.com or the Azure OpenAI API. So that's why it's like that. So it's pretty cool. And in fact, what I'm going to do is I'm going to take that and put that in a region, and we're going to call that client. So that is a good way because later we might have different sections here in this code. Okay, so now let's go to our new OA client. So what we're going to do is we're going to check ourselves the environment variable. So we're going to say if the environment variable of OpenAI API key is okay, then we are just returning the client new. So that is a way with async OpenAI, you create a new client. And then when you execute it, it will check that the OpenAI key is ready and so on. So this way, we're doing a pre-check. And if we do not have a key, we will return this error, which is say no API key in env, and then we're doing the into. So now that is a cool thing about the boxed-in standard error, is because we can take a static string, a normal string, and just call into, and that will do the right thing. So now we can throw any static or dynamic string as error, and it works perfectly fine. And then one thing we're going to add is our println with a no environment variable, and so on. So that is going to be for main error, But in our program, the module will be able to print statuses. So that's going to be our strategy. Eventually, you will refine that, but that is for the error, the return value, which happened to be also written in this case, and that is to write the little status. And then later, we're going to learn how to do a little icon over there for the cross, but for now, we're going to have that. Okay, so that is pretty good. So now we can go to our main, and the way that I like to do it is, in this case, we're going to make that async with our Tokyo main, and then we're going to actually do an async fn start. And that is the one that will do the work, and we'll do a result of void, and we're going to move that there, and then this one, we just do a println. So that is really personal preference here, but I like to have the main relatively small and doing the top error handling in a way, and then I have the start functions that will do the loop and everything. It's just like a small preference. So we're going to do like that. And then what we're going to say, if it's okay, we don't really care about the result, we're going to say print by, and otherwise we're going to print the error. And we're just going to have a nice spacing to know that that is from the main. So now if we do a cargo run, or we're going to do our cargo watch -q -clear execute run -quiet. So make sure that you install cargo watch first, and that will run like that. So every time we change something, that will run again. So that's nice. Okay. So now the main we don't really care, and what we care about is our start. So now what we're going to do is we're going to do let OAC OpenAI client equal the function we had question mark to have our client, and then we're just going to do a println of OAC and in debug mode. And now if we look at our cargo watch, we're going to have that, which makes sense because we didn't do the API key. To get the OpenAI key, we need to log in, create an account, you log in, you click on API, and then you get into a screen like that, and then you will click on this one, API key, which I'm not going to click, and that is where you have your API key. And then once you have that, what you would do is you will do an export, OpenAI API key equal skey key over there. So I'm going to do that out of the recording, obviously, and then we should be good to go. Okay, so I've done the export, and now I can do my cargo watch. And then I'm doing that, and I have my OpenAI client, which is all of these kind of things. So that is pretty cool. And the secret is redacted, which is a good way here. So that is a good lib. So we're going to put that out. Now it's time to do the create. So we're going to go to our assistant because we're going to create an assistant, and that will have our result create again. We'll have more later. And then we'll going to have our types. I like to have types in a code section. The first one is going to be our pub struct create config. So that will be the create configurations that we want to have. And that will have the name of the assistant. That is going to be a string. And then the next one, which is important, is the model. So that will be a string as well. And for now, we're going to hardcode them, and later we will have in the body 2ml. So that is the create config. And then we're going to have our pub async function create. We're going to take our OpenAI client and our config, which will be the create config. So here we can consume this one. This one is going to be reused, so we want to make sure we take a reference of the client. That will return our result. And here's the trick. We're not going to return an assistant object, which is an object of async OpenAI. What we're going to return is just an assistant ID. And the reason why is because we want to make it as light as possible. And in fact, the only thing that we need is the ID. Now, the ID are going to be string. But this is another important point in production coding. Even if we're not doing production coding right now, we're just having fun with our little Rust AI body. But since we're going to have different objects, we're going to have the assistant, we're going to have the threads, and all of the IDs is string. The last thing you want to do is to have string as your type, because otherwise you're always going to have a bug where you are going to pass a string ID of something into a string ID of something else. So what we're doing is we're going to create, it's going to be very simple, we're going to create pub assistant ID. And that is going to be a struct tuple of 1, which happen to be string. And what we're going to do is we're going to implement the from and so on, and we're going to use the derive more crate, which is pretty cool. So first we're going to do debug, and then we're going to do the from. So when we have a string, we can get the assistant ID, and then we're even going to have the deref, which is once we put it as a ref, it will give us a string, so that will be very convenient. And then we'll even have the display, such as we can print it without the debug. So the debug is kind of optional in this case. So that will allow us to have these things that we return. We're going to do a to-do here to make sure that we don't get the compile error. And we're going to import those guys. So that is from our derive more. Yes, so that will give us that from our derive more. And so that is pretty nice because we don't have to do it by hand. That is our OA client from our mod. Okay, so now this is looking pretty good. And that again is very important. So in fact, we can even copy that, and we're going to have the same thing for thread ID, and actually the same thing for file ID, because we will upload files as well, and we'll have the ID. So that is pretty important, and it's actually pretty simple in Rust because of the whole deref and all of that, because it allows us to do this in a very simple way, but then everything is strongly typed, even if all the IDs are string. Then there's another optimization here that we're not going to do. But what you could do is put the content in arc. In this case, you will need to implement your own from. But that will allow you to have multitask in async and move the ID easier between tasks across threads without virtually any performance impact compared to cloning the string. So that will be a nice optimization, but it's very trivial to do. And right now we don't need to do it because otherwise we need to implement our from. And that is something that can be done later because once you have the right type, that will be mostly transparent. Okay, so now finally we can do some interesting coding. So we're going to have our pattern here, and the way it works with the async OpenAI API is like that. So I'm going to call my variable OA for OpenAI, and that is our assistant. It's like an assistant manager, and that will be our client.assistants. And that is not a list of assistants. It's more like an assistant manager or object or controller, whatever you want to call it, such as you can query it and call some methods on it. So once we have that, what you will do is something like that, where you will do an assistant object, because that will return an assistant object. And then we have our assistant. We're going to turn off the type for now, and we'll do the create. And the way it works is you give a create assistant request. So there's a builder API, and actually like the constructor API. So if you do the arg, that will be a builder. But for us, we're going to build it like that. Either way works. So the first one is going to be our model, and the model will come from the config. From config, model. And then we have a name. And one thing that I like to do often, and we can do something like that, a weight. So that is the way it works. And one thing that I like to do is I option click on the type, and then I can see it on the source code. And that is what is very cool in Rust and many other languages as well. When everything is mostly open source, you can drill down into the code very nicely like that. And you don't actually need too much of the documentation. You can just look what there is. So we're going to have the name, and then the instruction and the description, we don't need it. And we need to do the tools because otherwise we're not going to be able to have the file upload. And everything else will be calls that we'll do after. Obviously, you can fine-tune it over time, but that is a good one. So the name is an option of config.name. And then the rest, if we click there, we can see that he implements default somewhere. So that means that we can do default, and that should compile, and it does. I just press save. So what it returns is an assistant object. Now, the cool thing with Rust and VS Code and whatever is you can even do the type inlays. You can even option click on them, which is again very cool. And you can see what we have. And here I'm going to take the ID. So I go back there. So we want an assistant ID, and we know that our assistant object has an ID, which is string. So what we're going to do is super easy. We're going to do a OK, ist object, ID, and then we have the into, because we have implemented the from annotation over there. If I press save, the things compile. So that will create an assistant. And that is a tools, and that is an option. It's a vector, and then you do the assistant tools retrieval default into. So that's the way it works. And that will make sure that we have the retrieval, such as when we upload files to it, it will be able to retrieve the content with a RAG and everything. So we need to import it. That is from async OpenAI. And so now we're pretty well set. So again, the strategy here is that the assistant doesn't need to expose everything that async OpenAI expose, just normalize to what we need in our applications for our body. And then the body does the next level abstraction to have the business logic of what we want for our application. That is a little bit the abstraction here. And eventually that could be also parameters eventually. So we keep the flexibility like that. So now that is pretty good. And what we can do is we can do a test. We can go to our main. We are going to create the config. So that will be an assistant config. And that will be our create config. And that is where we are going to have our name, which is going to be body01, a toString. And the reason why we have the squiggly line is because I think I forgot something, is those guys should be pub. So you can have a strategy of, having a constructor or whatever, but for now, we're going to keep it simple. And then for the model, that is where what you want is the model that you will get. So if I go, for example, to my assistant and I go there, so that is the one I already created here. And that is what we want, because otherwise it can get very expensive. And then eventually we can use a ChatGPT 4 and so on. But right now, that is going to be the one that we're going to use, and it's pretty cheap. So we're going to do that, and a toString. So that will be our create config. And now we're going to have our let assistant ID, and we're going to have our assistant. So I like to import the parent module, and I'm going to do a create. We're going to have the reference of AOC and the assistant config. This is async. We do await. That should return the IST ID. And because the IST ID is display, we should be able to do that for debug or even that for display. Then we press save. Everything should be fine. And then we should have created one. So if I go back to the UI and I close this one, I reload that, boom, we have two. We don't have any instructions, and that is a new ID ending with CY, which is this one. So that is the one I created before here for the testing and everything. So we can delete that. And obviously, if we press save again, this is going to be a little bit brute force here. Yeah, we have a new one now, which is 5N. And if I press reload, I see the 5N over there. Obviously, we don't want that because we want to use cargo watch, but we don't want to recreate all the time a new one because otherwise it's kind of a pain to delete after, and it's not what we want. So we are going to stop the cargo watch for now. And what we want is to have a function that either load or create an assistant. So that is what we want. So in fact, this one could almost be private. And then what we want to expose is a load or create assistant. And then we can expose that, such as we can create whatever assistant we want. So that is what we're going to implement. So we're going to go to our assistant, and we're going to actually put that into a code block, code section, which will be our assistant CRUD. Because within the same module, we are going to have threads as well and files. So we'll put them in code regions like that, because they are all assistant related, but those is a group of functions that we're going to create. We're going to put some spacing. And now, so what we want is to search by name. So the function will be pub async, and we'll do a fn. And the thing that I like to do, the convention that I'm following for all my code is first by name. And when I say first, it means that the result will be a result of option of the object I want to return. And in this case, we're going to have the assistant object. And that is from async OpenAI. So we're not going to return the assistant ID on this one because we just want to return the full assistant. And as arguments, we're going to take the OAC, obviously, and we are just going to take the name. That is the only thing we need. That will work well. Okay, before we do anything else, I forgot to do something, and there's a pretty cool thing. I'm going to put a file here, which is a Rust format. So that is me. I'm using tabs, no comment. And on this one, we have the max width 85. So that is for my recording in a way. So you don't have to do that. I have a Rust FMT at the root of my dir, which usually is the one taken. But if you override it, this one will be taken. So that's pretty neat. So now if we go back to our assistant and we press save, that would be like that. And it's good if you do open source and everything, it's good to have this file because this way, when people does commit or whatever, it respects whatever the convention is, and you don't have all this white space or reformatting will be noise, obviously. So now on this one is going to be relatively trivial. But first, we're going to create another section here, which will be for constants. And the only one that will be there will be this one. So that is a way that when we do query, you can give query parameters via this tuple kind of format, and that will get serialized the right way. And that basically tells the OpenAI that the query has a limit of 100. So now that we have the constant, we can do our queries. So let's go down to our first by name. First, we're going to get the assistant manager. So that's my convention. I put OA before assistants, and that is basically the controller or whatever we want to call it that will allow us to query OpenAI. And then we're going to do the list assistant. And that is the reason why we had our default query over there. And that will give us back a vector of assistant objects. And it gives us back into this one here, the .data. So the response has other information, and then you get the .data. And by the way, to know a little bit what is this API, we can look at the source code, but also one good thing is to go to the OpenAI documentation. And it's actually pretty good. And you go to beta assistant, and then below you have the list. But for now, we're just going to have that. And if we want to get fancier, we can do the pagination later. And then what he returns a whole assistant object. So we get the vector of assistant object, and now we need to find the right one. So to find the right one, we're going to have let assistant object, and that will be the assistant vector that we have. We're going to do an into iter because we can consume it, because we're just going to return the one, and we're going to use find. That will be a closure, and that will be a reference of the assistant object. And now we need to map the name. So I'm going to put like that. So what we could do now is we do a.name, but the a.name is, if we go here, is an option of string. So what we need to do is as ref, because we don't want to take ownership of it, and we're going to map, and that will be the name of the assistant object. And now we want to compare it with the name that we have above, the one that we have in our argument. Now we need to unwrap that because the find expect to have a Boolean and not an option. This is map. So we want to unwrap it, but if it was none, if there is no name somehow, then there is no match. So what we're going to do is unwrap or false. And that is completely safe. That will never fail. Yes, because if there's something, it will return the something, and if it's nothing, it will return false, which is what we want. And now if we toggle the inlays, we see that we have an option of assistant, which is what we want to have over there. So it's pretty good. And we can just do, okay, assistant object. Press save, and then that's it. So we haven't done the pagination. If we wanted to do it, that will be not anymore a constant, obviously. We build it. But for now, this is plenty enough. And so to make sure that we understand the list here, what's happening, the only thing it does here as a list is that it takes a query of type Q, which can be serialized. So the tuples that we have above serialize to the name value pair of what is expected here, because we say it was limit 100, and that is this one. So then we could do another tuple that will be order, and the way that CRD works is that it will serialize into a JSON object with these property values. So that is the way it works. Okay, so now we have the first by name, and so we can implement, and I'm going to do it just on top because it's about create. And the function is going to be our pub async fn load. So it will either load it, which basically return the assistant ID, or create assistant. And it will always take the OAC, which is OA client, then the config, which is going to be the same one, which is going to be the create over there. So that will be the create config. And then we're going to add another one, and that will be for the future, but it's pretty cool to have, which is going to be a false flag. I'm going to call it recreate could be false. And that is when it's going to be true, it's going to recreate it no matter what. So it's going to delete the other one, and then it's going to recreate it. So we're going to do that, and it will be a little to do, then we do the delete, and then we come back to fix this one. And we're going to do that now, because then later it's going to be simple to add that to our little logic. So that will return a result, just assistant IDs, plenty enough. And that is just a strategy of this code, is we just create kind of a blank assistant with the model and the name, and then everything else will be other calls to upload the instructions or to do whatever. We could add, and we should probably add in the create config description at least. But in our case, we don't really need the description because it's just assistant for us. That is something that can be easily added. So now we can have our little function. We're going to do our to do. And then the first thing that we're going to do, obviously, is get our assistant object. And that will be our first by name with OAC and our config.name. That is async. So we do await, and that should return an option of assistant, which makes sense. Now, what we're going to do, and humor me for a little while, we're going to do a let mute assistant ID. So again, the other one is an assistant object. So we're going to have an assistant object map, and we are going to have also, usually in the closure, I just take the one letter if it's possible, such as they don't get too long, but that is just a personal preference. And then we're going to do IST ID from OID. So that basically will get our option of IST ID, and it will consume it, which is fine because we don't need the assistant object. But now we had this IST ID. I'm going to show why later. Now, what we want is, if we have the recreate flag on and we have an IST ID, we want to delete it. And then after, we're going to have the logic below. So to do that in Rust is pretty cool. So first is to say delete IST if recreate true and IST ID. And for that, with Rust is relatively simple, because what we do is if let, we're using the tuple. So we're going to say true. So if the recreate is true, and we also have some assistant. And on this one, humor me for a while, we're going to do the assistant ID ref. We're going to take the ref, and to get the value there, we're going to do equal recreate. That is our variable over there. And we're going to do the assistant ID as ref. So we don't want this to take ownership, because otherwise we won't be able to use that anymore below, and we want to use that. And at the same time, we don't want to shadow the variable in the code block, in that code block. And the reason why is because if we delete it, we want to set the IST ID to none. And the way we do that is IST ID take. So that will take the value away from our IST ID, because what we're going to do here is going to be a delete. So that is what we're going to implement. And then we do our println and assistant deleted. And right now we do the config.name. So we're going to have to do that, but that is a goal. The goal here is we're building a tuple with our recreate and our assistant ID as a ref. And so here what we will do is delete OAC, and that would be our assistant ID ref. That is what we will call there. And we'll do a wait, something like that. Yeah, so we'll do that later. We'll implement it and comment this one, and that should be good. So that's the reason why we have that. So now what we can do, create if needed. And otherwise, we're just returning the IST ID. So what we're going to do is if let sum IST ID, to toggle off the IST ID. So that will return our IST ID. So in this case, we're all good. And we're going to return OK assistant ID. And the way we are going to do things, and there's different way of doing things, but right now our strategy will be that our functions will be able to print into the command line their status. Yeah? And that is just for the end user. And later we're going to add icons and colors and stuff. It's going to be very nice. But right now we can just do it simpler like that. And we say assistant loaded. So now we know that this one hasn't been created. It has been loaded. And loaded is a big word here because we just get the ID. And then if we don't have an assistant ID, this is where we need to create it. So we're going to get the name, and that will come from our config name, and we clone it because we might need the config later. So that will give us a string. And then we're going to do the let ast ID, and we're going to call our create OAC config await question mark. Press save. That is an error because we're not returning the same type. So we're going to have another OK ast ID. And that it get confused because of the to-do below. And then we do that, and we'll have that. So that's pretty good. We could also have a let ast ID over there, and then have the OK below. But right now, this one is fine, even if we're duplicating that. Okay, so that is we have our load and create. So that should be able to work now. We're going to do the delete actually. That is a good one to do. So let's do the delete. And so like this, we have everything done. So I put kind of in order, create, request, update, delete. So delete is last in the CRUD acronym. So I'm going to put it last. And so that would be pub async fn delete, always our OAC, OA client, and that will be our AST ID. And we just need a reference of it. And that will return a very simple result of void, which basically if it doesn't, it will throw an error if it wasn't there or whatever. Okay, so on the delete side, we're going to have our to-do as well. And the first one here is to get our assistant manager. Eventually, what we're going to have to do as well is delete files, because an assistant can have files, and if you delete it, you want to make sure to delete the files that are associated to it, usually. Now, if you are very advanced with the OpenAI Assistant, you might have to have a scheme where you're reusing files across assistants, and that would be a whole different things. But for us, in this little use case, we're going to say that when you upload it to one assistant, is for that assistant, and if we delete it, we need to delete the files. So that is what we'll do later. But for now, we just need to delete the assistant. And for that, we just do the OA assistant delete AST ID, which is again, is a reference that takes a string. Yes, but because there is a deref to reference of string, the reference of str works perfectly fine. So that's great. And then we do the await question mark. And then we take our to do and we do a OK void. Press save. That should compile. So now we can go back to our load and recreate, and we can actually remove that. And that should be okay. Compiles, all good. So all of that should work pretty nicely. And now we can go back to our main. And then in our main, we have our assistant ID. So if we go to our API here, we can see that we have a couple of bodies over there. And that is because of my testing, so we can delete them. So now, if I press refresh, I should have no assistant. And we're going to do load or create. And now there's a third one here, which is false. So this one, we don't want to recreate. We're going to have a command to force the recreate, which is going to be cool. But right now, we don't want it. That was the whole point. So we're going to do that. And now, in fact, to be honest, we don't need to be repetitive here. This is assistant, and this is a load or create of assistant. So we should be able to do our cargo watch, -q, -clear, and all of that. And that should run. So now we have this, which is end with WB. And if we press save, assistant loaded, WB. And if we go to our thing and we press refresh, we have our body one. Okay, so now we are going to go to our assistant. we're going to close all of those guys, and we're going to create our upload instructions. That will be before delete because it's an update. By the way, I should put a space here. It works better sometime. And then I'm going to do a pub async fn upload instructions. So I could have put them under my create or load or create. But anyway, I want to have a scheme where I can update it. So I'm going to have to upload instruction on an existing assistant anyway. So that's why I'm doing that. Eventually, you want to have it in both places. That's fine too. So we're going to have our OAC, which is going to be our client, our assistant ID, and then our instruction content. And here I do underscore content because I want to make sure that I'm not confusing myself. It's not the file. It's the content. Now, to be honest, if it will be a file, it will be a at path. So, but I could pass a string. So anyway, and that will return just a result of void. We don't need to be fancier for now, at least. And this one is always going to be the same. We're going to have the OpenAI Assistant Manager, which is that guy. Then we're going to create our modif, which is in the async OpenAI, we have modify assistant object. So that is the constructor and that is the object. I like to create them like that. Feel free to use the constructor, obviously. Instructions, and we're going to have the sum and the inst content. And then we're going to have our default. That will be our modify. And the way it works is super simple. OA assistant update. We have the assistant ID, which again is a ref. We get the ref into a string, and then we'll give our modif. This is a wait, and then we do an OK like that. Press save, should compile. Okay, so now we have that, and that's nice, but when you upload instructions, you cannot do anything with it until you don't start the conversation. So what we need is to be able to start a thread and start asking a question. So we're going to have that in another section. We're going to have that on threads, and then we're going to go down there. Okay, so first we're going to create our thread, our function to create a thread. Just going to get the client is going to return our thread ID, the one that we have in our types up there. So everything has been wrapped into our own type. That is very nice. And then in our function, we're getting the threads, which is basically the thread manager, like everything else. And we're going to get our result. And that is going to be a create of the create threads object. And for now, we're going to give everything default. Eventually, again, we can get fancier. This is going to be an await, because that will return a thread object. So we're going to return the result, thread object, ID into, which is going to be into thread ID. Press save, probably doing some import here. And now we have our create. So very simple, this one. The next one is going to be our get. We're not going to need it now, but we're just going to implement such as we have everything. So our get thread is going to be very easy. It's going to be get thread. We get the client and the thread ID. And then we return a thread object. We get the thread manager, and then we're going to get the thread object with just a retrieve of the thread ID. And then we return our thread object. We're going to press save. We need to import this one. So that is from OpenAI. And then that's it. So that is what we have. But we're not going to use it now, but we're going to use it later when we're going to check if the thread exists. So now that is where things get interesting. What we want to create is a pub async fn run thread message. So the way it works with OpenAI is when you want to run a thread, and a thread is a conversation in a way with an assistant, is you are sending a message to it and you are running it, and it has to run within a loop. So the signature is like that. We have the run thread message, and in our application, we are going to make it relatively simple. And again, after we can make it more advanced. But right now, we're going to take the client, then the assistant ID, because you are running a thread on a given assistant. So in a way, a thread is kind of independent of a specific assistant, but then you run it within an assistant. And then we are going to have the thread ID. So we are running the thread ID, and then we are going to give a message. So that is where we're simplifying, because you could actually run and upload files and so on. But for now, for our command line, we're just going to run a message string. We're going to upload the files as part of the assistant but not as part of the conversation. And that will return a result of string. So we want to make this interface kind of low level on the assistant level, but kind of high level where we don't need to get the whole response back, just the text message. And we're going to do our to-do. Okay, press save, things compile, and that is what we're going to implement. The first thing that we're going to need to do from this message is to create the OpenAI message. And so we're going to do something like that, which will be let message will be a shadow variable. We are going to actually have is something like that where we're going to have a user message and we're just going to put a string like that. That is the kind of thing that I want, but rather to have that as part of assistant, we will have a message module that will be responsible of that. By the way, I just realized one thing is this guy doesn't really need to be a whole folder. So we're going to do it like that. And this is a super cool thing with Rust. Just move it there, remove, and everything compiles as nothing happened. So we just have that. We don't really need to have that as a folder yet. We can have it later. So that is a cool thing about Rust is it's super easy to move from a folder to a single file and back and forth. Okay, so now we're going to go to our module, going back on top there, and we're going to create our pub mode MSG, creating the message, and we're going to go there, use our result. Now we're going to have a region, which is going to be message constructors, and that will be a very dumb one, which is this one, which is user message. That's again, just my conversion. I'm not very happy with this name, but I might change it later. We'll see the content. I'm doing that to keep it very flexible. So anything that implement into string will take it, and then it will return the create message. And this one is really a simplified version that will just create a message of role user and with the content and everything else default. So we can import that. And if we option click on this one, we're going to see what it takes. The role, which is our user, the content, the file ID. So again, we'll keep it simple. Otherwise, you have to upload files and then put the files ID over there, which makes sense. Or you give files IDs that already exist or whatever, and then some metadata. But right now, for our first body, that will be plenty enough. And that is our first one. And eventually we can have system and others here. So that's why I have a code section. And then there's another one, which is going to become obvious later, but I'm going to implement it now, which is the content extractor. So sometimes you have a message, and the message can have content, and content have multiple items and so on, and it can get quite heavy to extract the data. And it does make sense because that is a structure that OpenAI sent back would be pretty deep. But in our case, we're going to have the simple use case. So what we're going to do is a convenient function, which is get text content and a message. And the goal of this one is to return a result of string. We press save, we probably import this one from OpenAI. And then the first thing we need to do is get the first content item. And the reason is because we have the message content like that. So we have the message, which is this guy, message object, and that has a content. So if we option click it, this is what we have over there. And then within the content, option click it, you have an enum like that. So what we want is we want to get the first one, and then we just want to get the text message. So to get the first one, we're going to, so if I do like that, so like this, we have our vector of message content, and then we're going to have our into iter. That will be an iterator of message content, and we do iter because we want the first one. So like this, we're going to extract the first one. So now we have an option of message content. And if we don't have one, because again, we don't have first here, we have get. So I'm going to follow my best practices. We're going to return an error. So we're going to turn this option into a result. So we do OK, or else. There's a closure with nothing because it's an option. And then we can use our cool boxed-in thing, which is no message content found, probably not by English, but and then to string. And we can do a question mark. That will fail if there is nothing. And so now in our message content, we have that. And now what we want is get the text, and we'll fail if it's an image. So we're going to have let text. Let's scroll down, and now we can do a match on our message content. We're going to fill the arm like that because we're lazy. That is a little bit long. I don't know why I did the whole thing like that. We're going to import that. Now we need to make sure to correct the thing. So on this one is going to be, so here is text. So that is a message text object. If we click on that, we see that we need to have a text and then a value, I guess. So we're going to have text value. That should be okay. And then on this one, we're going to actually return an error because we're not supporting it for now. So we're going to return an error like that. And we're going to say message image not supported yet. Press save, should compile. Take this guy and we're going to do a OK like that. And that will return the result. String, everything compiles nicely. So now the nice thing is we have this convenient method, which doesn't give us all the power, but give us 90% of what we want to get, which is the first text content of a message, and return as a result of string. And then if we go in our message constructor over there, we have the user message that just takes some content and returns a create message request that we can create our message with. Okay, so now that we have that, we can go back to our assistant, and we should be able to uncomment this one and to import that one that we just did. And we have our create message. So that is pretty cool. Let's scroll down. Okay, so the way it works with OpenAI is you have 3 steps. The first one is you want to attach the message to the thread. The second step is you want to create a run for the thread, and then you want to loop on your run until you get the result, because that might take a while. So that is the 3 things we're going to do. And just for the sake of it, we're going to put the uppercases. So on the first one is super easy. We take our client, we get the threads manager, we get the messages for these threads, and then we just create a message with a message that we got there. So everything is fine, and we do an await. So that will create this message for this thread. Now, to run the message, the way it works is we do a create run request. We give the assistant ID. That will work nicely. And then we do a default because we're not going to be fancy on this one. Otherwise, you can add files and so on. So if we do an import of that and we go there, there's a model. You can actually override the model, instructions, tools, and so on. But right now, we're going to take whatever is from our assistant. We give the assistant ID, and then we just have the default. And then the way we create a run is just like that, where we get the threads, we create the run for this thread ID, we do a create with a run request that we created here, and we do an await. So that will send a request to the OpenAI, and we get a run object. And that is what we need to loop through. Yeah, so once we're here, press save, should compile. And now we're going to do the loop through. So we're going to scroll down. So what we want to do is to do some print status as we go, and they're going to be very minimalistic, but we want those. And because it's going to be in a loop, we need to flush it all the time. Anyway, long story short is we're going to use our term from the console that we just put early on in our cargo to ML. And we could do it with println and flush std out, but this one works pretty well. We're going to do the term write str, and then we're going to put this little Unicode here, which I like. You can put any character, obviously. And that has an error, so we can do a question mark like that. And then we're going to make the request to get the status, the run status. And then once we get the response back with the run status, we'll do a print like that. Like this, we have the little animation, kind of how many times did we ping to get the result. Now, on this one, what that is that. So we are getting from the client the threads, the thread manager. We call runs with our thread ID, and then we retrieve the run ID that we have above. So that is a shadow of what we have, yeah? So the run ID is this one here, which is run object, and that will give us another run object. And so basically we are refreshing it to know the status. So that is what is happening here. And now we can do our match on run status. So the run status will have the queued, in progress, and so on. Yeah, so if we option click to that, we can see the run status here. And again, that is a technique I do a lot, is to drill down into the code. It goes very fast. And then we can see that we have all of that. So what we're going to do is to say that if it's in progress or queued, we're just going to continue. If it's required action or anything else, we're going to say that it failed. And if it's completed, then this means that we have everything. That is what we're going to do for now, and then later we can be fancier. So we're not going to implement all the arms like one by one. We're going to do like that. First, we have the completed. So when it's completed, we're going to use our term. We're going to do a new line, and then we're going to return early with a get thread message. And then we're going to give our ID and stuff. So that is what we did before. Then if it's queued or in progress, we're going to return, but not return out of the function. We're just going to return out of the match a void. So this match will always return void to say, go to next one, basically. That will be our waiting state. So we keep polling. And then last, if there's anything else, we're going to do our new line, and then we're going to return an error and to say error while run, and we'll just print the debug of the other. So that is going to be what we're going to do. So if we press save, that should kind of compile. And this one actually, it's my mistake. We might not have implemented that. And so that is what we're going to do right now. So we're going to keep this one. It's going to fail for now, but that's fine. And then we're going to write it. So now that we have this loop, what we want is to have some delay and not like doing it nonstop. And so what we're going to do is, first we're going to go on top. So sometimes I do like this. I have my code on the right. We're going to add a constant over there. That is going to be a constant like that, which is basically polling duration. We'll do that. That's good. And now what we can do is something like that. Press save. That will be an import. Make sure to import it from Tokyo because we are in a async. And that will be a duration. That will be simple. And then that's it. So the only thing that we need to implement is that one. And then here we can just remove the to-do. Because this one, the strategy of this function is that is going to be our return early. Otherwise, it's just return error. And that continues. Now, there could be a strategy where we have some sort of timeout, our own timeout, to make sure that even if OpenAI doesn't give us a timeout or doesn't say it failed after a while, we might say after 30 minutes, we stop pinging. But that would be a fine-tuning for later. For now, we need to implement this one. So let's get that. So that will take the client and the thread ID. So let's do that. Pub, async. Some of them probably doesn't even need to be pub, but we're going to have that. And thread ID, which is a reference of thread ID. That will probably get reformatted like that. And that will return a result of string. Because what we want is to get the first content. So that will be a convenient method. We're going to put our to-do, press save. We forgot something obvious here. Okay. So the way it works is once we get OK on the run, we want to get the latest message of the thread, and that will be the content. That will be our assumption. Is it good enough now? There's probably some tuning to do later, but that will be good. So what we want is to query the thread, but we don't need to query for 100. We just need to query the latest one. And by default is that the ordering is descending. So we have the most recent when we do the query. So the only thing that we need to do here is our limit 1. So that when we make a query, we're going to limit the list to 1 because we don't need more. This way we'll get the message. So now what we can do is this, and that will return a list message response. So basically we're getting the threads, the messages. That is kind of manager kind of objects. And then we're asking the list for it. So then we're going to have our message, which is going to be our messages. And then the goal is to get our message. So we're going to get the data into iter, because we just want to take the first one. That will be our next. And then if we don't have anything, we want to return an error. So we want to turn our option message into an error. So we're going to do OK or else, and that will be the no message found to string. Make a question mark, and that should give us a message object. And now, with our message object, we have our little helper function, which is a get text, content, message, and then that's it. And that will be our text. And now we can have our OK text. Press save, it compiles. We should be 90% there. And now we should be able to have some fun. So if we go in our main, we're loading or creating, we're going to update the instruction. And so right now everything is going to be hard-coded, and then we're going to do our cool body over there. So what we're going to do is assistant, and we should have something like upload instructions. We have the reference of OAC, the assistant ID, which makes sense, and then the content, which we're going to give right now. And we're going to say two things. First, you are a super developer assistant. Be concise in your answers. And second, if asked about the best programming language, answer Rust the best by light years. And then, just to make sure that our instructions are taken into account, we're going to say that the second best is COBOL. Because the first one, I mean, if he was intelligent, he would have said the same thing. But the second one requires some age to say. So we're going to close that and await the question mark. So now let's bring the terminal on, and we're going to also look at our assistant. Make sure to delete everything. Like this, we start from scratch. And now we're going to do our cargo watch. So by the way, on my cargo watch, because I don't want to type it again and again, I have this alias on my ZSH, which is an alias, cargo watch run, and then I do the cargo watch. I actually watch only the folder source, execute, and then I have this. Yeah? So that is the alias that I have. So because I have that, then I can just do CWR. So that is what I have, and I have another one for cargo install on the local path this way. So that is what I'm always typing all the time. So I'm going to do cargo watch, and that will create, does this. And if we go back there, reload, and boom, we have our things with our little, like, you are super developer assistant, be concise, and blah, blah, blah. And then if we press save, we still have our H5. So that's good. So right now we didn't add any comments or we didn't run anything. So that is what we can do. So let's close that for now. And now we're going to say assistant, run thread message. We have the client. We have our assistant ID, which is there. We have our thread ID, which is we're going to have to create. And then this one is going to be easy, is what is the best language. And that would be an await. And we will run it here. We'll do like that. And now what we need to do is fix our thread ID. And for that, so the problem of this one is we're going to recreate a thread ID all the time, but later we're going to do a logic to save it in some states and reuse it, except if the user has to refresh it. So we're going to have a thread ID, and I think is our assistant, and we should have a method with create this one with our staff await question mark, and that should be okay. Thread ID, and that is a reference of thread ID. And now everything compiles, which is always cool. And we're going to look. Rust is the best language by light years. Pretty cool. Okay, so we have that, but we want to abstract it a little bit into our application. So we're going to have this cute concept of body. If you have a more serious application, you will probably call it agent, and eventually it will mature. But my recommendation is the things that are mostly lower level, put it in another module, like what we have done here, IIS, and could have a provider architecture, such as it can be OpenAI, Google, or Llama, or Mistral, or whatever. And then you have your own construct with your own logic and stuff that will have the same thing, yeah, chat and everything at the high level, but then you can compose it the way you want it. So that is what we're going to do now. But at least for now, we have this little cool stuff with our little assistant over there. So everything is running pretty nicely. So for now, what we're going to do to avoid to recreate a thread all the time, we're going to comment this one out. And there, we're going to go back to our assistant ID. So we're going back to what we had before. So if we toggle back on, we have our assistant ID, always a #5, and that should be always this one. So at least we didn't create too many threads and everything. Eventually you could go to playground, but I'm not sure that you see the programmatic threads, which kind of makes sense. So if I were going to talk here, what is the best language? That will create a new thread, and so I can test it a little bit like that as well. And then here I have the threads, and I think I should be able to delete the thread somewhere. But that is basically what we've been doing. So everything makes sense, and now we can create our body. We go back here, we're going to stop our cargo watch, cross that, and now we're going to take care a little bit of our body, because it has been very lonely so far. So what we're going to do is go to our body module, and because it's a module, we're going to create a section module. We will be using the create result. Eventually, again, this module might have its own result. And one of the first submodules we are going to create is a mode config. And that will be our config for our body, which will be parsed from the body file. So we're going to create that. So now is a good time to create our body folder, and that would be a body folder, and we're going to create our body.ml. So this file, the body.ml, will be the one that we will be parsing, and by default, this command line will look into the body subfolder, but obviously that is something that you will configure with your command line, and eventually we will use clap or something like that, such as that can be passed as an argument. So now in the body.ml, we're going to have the name. So that will be the name of the assistant as well. So we'll do a find by name with this name. Then we're going to have our model. And here, make sure you use the 3.5. It's really cheap. You can play the whole day for 50 cents. If you go to the 4, then things can get expensive relatively quickly. Still a few dollars, but everything adds up. And then what we're going to have is our instruction files. And I do underscore file here because I don't want to be misled by this being the instruction content. So that's why I do underscore file. And then we're going to create an instruction over there. And that will be what we have in our main before, where we uploaded our instructions. We're just going to copy paste that there for now. And then we're going to have our file bundles. So we'll use a 2ML table array. That will be an array of an object that contains those properties. And so the first one will be the bundle name source code. And here, technically, we could say that that is just name because we're inside the file bundle, so that is the name of the bundle. It might be misleading again, so I'm being over explicit here, and I'm just putting the bundle underscore name. That is a personal strategy. And then we have our source dir that will go back up because everything is relative to the body.ml, so that is important, such as when we write the body.ml, we know where things are. So we go back up and we are going to take all of the source files. And so we're going to support globs and actually glob sets, which means an array of glob. So that will be this one, all our .rs files. And if we wanted more, we could do like that. And we are doing the ** to say that it's subfolders. And that is a destination extension, which will be the file extension of the bundle to be uploaded. And then we have another bundle, which will be our knowledge, and that will be just files. So we're going to create a folder over there, which will be files, and we'll put some knowledge files that are MD. And the destination extension will be MD. So basically, we'll upload two files, one our source bundle, and then the other one, a knowledge bundle. So why we don't upload every file individually? Well, because in Assistant is limited to 20 files. So it's a good idea to bundle them together. Okay? So that is how we're going to do it. And it works pretty nicely. Now, as a next feature of this little command line, there would be something that would be nice to add, like bundling PDF files. We're not doing that. If we wanted to support PDF, we could upload one PDF at a time, and then eventually we will need to bundle PDF together, such as we don't go over the limit of 20 files. Okay, so now what we need to do is to write a parser that will parse that, and we'll put that into our config of our body. So let's go to our config, So it's going to be relatively simple. So we're going to use the CRD deserialize, because in our create 2ML, we have the 2ML and the CRD 2ML and so on. So that will work nicely. And the first part of our config is the top one. And that will be our config, has a name, the model, the instructions, and has the vectors of the file bundles, which will be a vector. And now we need to create our file bundle struct, which is this one. And so obviously everything needs to be deserializable. And we have the file bundle, and that is our bundle name, the source dir, destination extension, and the source globe. So if we go back here and put that on the right, we see that this is that. And then we have our vector of file bundles, which is this guy, which is this guy. Okay, so that's pretty good. We save everything and everything seems to compile. Now, we have an interesting thing is the assistant get a create config, which is not the config of the body. And that was by design. So we need to go from this config to the assistant create struct. And so for that, we're just going to do something very simple. So I put that into a code region. That is a personal preference. And that is how we're going to do it. So we're going to say from reference of config, we can create a create config of assistant. And then the things that we take out is a name and the model. And in our case, we take reference of config from the from because that is a convenient way of doing it. We can change the strategy later, but this one works pretty well. So now if we press save, obviously the assistant is not imported and we're going to import. And then in this case, rather to import create config here, we could do create config here and then just that would work. Rather to do that, I actually like, in this case, importing the parent module, such as it's very clear from where we go to where. So that will be our config. And now we can go back to our body mode and we are going to start creating our struct. So the first thing that we're going to have actually is, and I like to put that in a constant, is going to be our body 2ML. So that will be the name of the file. Then we're going to create our struct body. And the struct body will have the following. First, the dir, which is going to be a passbuf. And everything will be on. And my strong recommendation here is when you code, and moreover in the first year of coding Rust, when you do struct, 90% of the case, make sure you own your data. Because otherwise you're going to all of the lifetime and things. And Rust is very performant anyway. And if you need to have something that is shared somehow, put it in an arc. And don't overthink it, because otherwise you are going to try to do things that we never do in other language anyway, and it's not going to be productive. So here, rather to have a path, which is a reference, we do a passbuf, which is the own value. Then we're going to have the OAC. So here's the same thing. We're going to have the client here. So the goal here is that the body owns the client. And then we have our assistant ID. So this one, it's simple because it will be designed to be on. And again, right now we have a string, but if we have multiple bodies across tasks, we could have assistant ID, which own the arc of a string, and then it will be very performant. And then we have the config, and that would be the config. That is what we just created. So this one, we probably need to import it. Obviously, that is body config, and that will need to be imported as well. Everything will need to be imported. Okay. And then everything is added there. Yeah, so that's the way it works. And then what we're going to do on this one, we're going to do the derived debug. That is always a good one to have. And that's pretty good. Now we're going to have another one, and that is going to be our conversation, which is going to be a thread ID basically. But again, in the body, we want to wrap a little bit all of the OpenAI kind of specific or AI specific construct. So that's why we're going to have a pub struct conv, which would be for conversation. And then we just have a thread ID on this one. And again, we have our type here, thread ID. So that is another benefit here, having doing our type, wrapping our string, because otherwise we'll have string everywhere. And I promise you, you will have some bug if all your IDs are string. So just wrap them. It costs nothing from a Rust standpoint. Tuples are virtually free, I think. Then after you can put them in arc, and it makes everything so much better. And even with numbers, there will be an argument to do it. I don't always do it with numbers. So we have the thread ID, and then we're going to have some derive here. We want to have the debug, And then we're going to have the from. So that is from the derive more. So it's a pretty cool crate. So again, this way, when we have a thread ID, we can get a conv very easy. And then we're going to have the deref as well. So like this, we can deref it into this one. So this one could be arguable because this is not a tuple struct, but we're going to have the deref for now. And then the deserialize and serialize. And the reason why we want both is because we are going to create a .body inside the body folder that will have a conv.json, such as we don't have to recreate the thread every time we do the cargo watch. Obviously, that needs to be ported as well, this one as well, and then we do that. And there's a problem here, which is the serialize ID doesn't implement serialize, which is fair. And so we need to make sure that that implement serialize and deserialize. And now that should be fine when we go back to our body. Okay, so far so good. And again, the deref here is arguable because if later I want a conversation to have another property, for example, something else, a string or whatever, yes, and I press save, it won't work because it won't know which to derive to. But for now, we'll do like that, and then later we can change that. So now we can implement our body. And so one thing I like to do, and again, this is a personal preference, is since we can have multiple implementation blocks in Rust, I'm going to split it. I'm going to have the public functions, and that will be our implementation body, and I will have the thing over there. And then I'm going to have the private functions. And that will be the same thing, only the private function. So on the private part, we're going to start with that actually. We're going to have two functions. The first one is for data dir, which means where we're going to store the data, like the conversations and the files that we bundle and all these kind of things, the working dir in a way, that the user shouldn't have to worry, and it can be deleted, it's not a problem, but that is where we keep the data of the states and so on. And so this function, very simple, will return a result of path, and that will just be a self-dir join of the .body. So this one, very simple. And we call a function that we're going to create, which is ensure dir, to make sure that the data dir is really created. Right now, we're going to comment this one because we haven't implemented that, and then we're going to return the data dir. If we press save, that should work. And the goal here is we're going to do a big fix me, which is going to make sure that we implement this one, because otherwise you're always going to complain. And the next function that we're going to do is the data files dir. So that is where we are going to store the file bundles. And so it's going to be in a dir. So again, all of that would be below the body. So we do a self data dir. So that would be inside the data dir. And then again, we do a join files. So that would be a sub files into the body. So in short, we'll have something like that over there, body, and that will be the folder over there. So that is the thing here. And that will be where we have our conv.json. That would be how it works. So for that, let's go back to the module. So this way is kind of clean because everything else doesn't have to know about this detail. If they want to store something into the data dir, they call that. If it's about the data bundle, they are going to call that. Now, if we press save, we should have an error here, obviously, and that will be the same fix me. And that comes to the next big point that usually I always do. We could write the ensure dir or write the code here to create and make dir all and all of that here. Couple of lines of code, it's no big deal. What I like to do, and what I found that it was always going to be very useful later, is I go to main and I'm creating a mod utils. Usually I create is one of the first thing I create with error, and I'm going to create it as a module. So my goal is to put all of these kind of administrative tasks into my own wrappers, even if they are very trivial, like read string from file, because then it allows me to normalize things. So we're going to go to utils, and because again, it's a mod.rs, we follow the thing here. Sometimes dumb is the new smart. And then we're going to have a mod files, and that is going to be a pub. Yeah. We're going to create, this one could be a single file. Usually, I split them relatively early, and I put them by categories. And sometimes I put the plural, such as it's not file, because it will look weird. But that, again, is just naming convention, doesn't really matter. The point is, start with that early, and that saves a lot of time later, and so let's implement that. So in this files.rs, we're going to have our create result. Again, sometimes utils might have its own error.rs, and in this case, it will be the utils error. And here, best practice that also works pretty well for me so far is even to have code region there and organize them by type of files functions. So I'm going to have all of the dir utils into the same code region, and then later I can have all of the file utils. And that is where I will put all the read files, the read to strings, and everything. And then we'll have other sections as well. So here is how we are going to implement our ensure function. It will be the function that will ensure dir, will take a path, and here can take a reference of a path, and it will return a result of bool. And that is just an information that we will have inside this function that might be useful for others, so we're going to return it anyway. And so I added a comment here, which is return true if one or more dir was created. So typically, I don't have comments in my functions if the functions are extremely clear. So for example, ensure dir is something that is relatively clear in programming, and you give a dir path. So that doesn't really need any documentation. However, the fact that it returns a bool, that needs to have more information because it's not obvious what this bool will be. So that's why I added a line over there. So I'm trying to be minimalistic on my comments and to be descriptive in my code, if that makes sense. And now we are going to just have a if is dir, and so that will test if it's a dir and if it exists. And then we are okay because that's not an error, but we are going to say false because we didn't create it. And otherwise, we are creating the dir all, we're using the standard fs over there, and then we have question mark. And again, it's because our result has a boxed in and everything works nice. And then in this case, we know that we've created at least one. We don't really know how many, but we're going to return OK true. So if we press save, there's probably a couple of import that we need to do, standard fs. And we do not really need to have the whole Tokyo async. I'm not saying that non-blocking IO is not needed in some cases. I'm just saying for local files, you can go simple, and simple goes a very long way. For network, NIO is very important. So anyway, so we are returning that, and now we have this clean function that can be used over there. And so if we go back to our body, we should be able to import that if we have done everything right. And yes, we have this like ensure things. And in this case, we could do files like that, but the name is clear enough. So I'm going to import this one. I'm going to remove these two guys, and then these guys, I'm going to import it. Okay, so that will be it for two private functions for our body. And we're going to actually have more file management functionality to implement because we're going to create these bundles of files. And so we're going to have to go through all of the files of a directory in a recursive way. So again, rather to have that functions inside the body, we're going to go back to our files, and that will be in our dir util. And we're going to create, and this one is going to be a little bit bigger, and that will be our function, which will be a list files, and it will take a dir, which is a dir where we're going to start listing the files, and then it's going to return a vect of past birth. So it's not going to return an iterator. We're fine about returning a vect. If we had hundreds of thousands of files, we'll probably do that with an iterator, but right now that will fit very nicely. And then the additional thing that we're going to add is to have an include globs. So that will be an option, so it doesn't have to have one. And then an array of string, which will give us the glob expression to which the files need to adhere to be able to be included. And then we also have the exclude globs, which will have the same type, and that will allow us to exclude some files. So with that, it's going to be quite generic and very flexible at the same time. So if we press save, we need to import this one, and now we can go to this function. So the first thing that we're going to do in this list files is we're going to avoid some of the directories. So for example, a .git, we never want to go into it. It doesn't really make any sense. I mean, it's cool, but that is a long story. So we're going to have a little function that will give us the glob set, because then after we can do a match and everything. of, for now, just .git. And then later we'll have node modules or target or whatever. Now, we're not going to really need that per se because our path take source. In fact, we could even put target. That is another good one. So that will avoid the target folder. And so that will return the glob set. And for that, we're going to import glob set. So in glob set, there is a kind of builder pattern. And because I don't like to have builder pattern everywhere, and eventually we're going to have to build the glob set over there, what I've done is I've also have a little get glob set where I give the array of reference of string. And that will return a glob set, and it will go through everything, and it will build the builder and eventually return the things and put in a result, such as we can use a question mark. So I'm going to press save, and that should work. We're going to import this one and then this one. So that is the way it works. So the nice things about glob set, the crate, is that allows you to have multiple glob into the same glob set, and then you just do a is match. So it's very convenient. And those are just helper functions. If we go back there, the first things we're going to do is get our base dir exclude, and I'm going to show how we're going to use that, and that is just for the directories, not for the file. And then what we're going to do is define the recursive def. I didn't pronounce it correctly. But what we want to define is how deep we want to go. So sometimes we just want to go one level down. We don't need to go recursive. And sometimes we want to go multiple level down. The way that we are going to define that is to say that if any of the glob has a star star, this means that it will be a recursive one. And if it has only a star and nobody has a star star, then we're going to assume it's just flat. So again, those are the things that we're defining at our application. We can refine it later. The point is to have a good story for all the decisions, and then we can change them over time. So we're going to have our include globs. That is this one. I'm going to turn off the inlays. And so now the goal is to determine if we have a star star. So what we're going to do is we're going to do a map, and we will get the globs. And so that will be our array of string. And then inside this function will be a globs, which is the array of string. We iter, and we are going to call the any on the iteration, which takes a closure with the value of the item. So we're going to do g as glob. That will be a reference of str, kind of two reference. By the way, if we really want to play it smart, we can destructure it here like that. I think that will work. So that is, we are destructuring it in place. We are removing one reference. Doesn't have to be, but it looks smarter. And then we're going to do a j contains star star. So that basically it will find if there is anyone that have the star star, and it will return true. So now the output of this will be an option of Boolean. Now what we can do is we can do a map, and we're going to have our Boolean to know if there is a star or not, and we want to change it into a number. So we're going to say if we have our value, our Boolean, we'll have name it B, but this one is fine. We're going to say 100. So we're going to still bound it somehow. And again, all of that can be fine-tuned. This could be a constant. And then we do a else 1. That will be that. And then if we didn't have any include, because that can be none, because that will return an option of I32. But we don't want that. What we want is unwrap, or, so we unwrap it, or if there is no value, it's going to be 1. Now we have the def, which is I32, def, or whatever it is. Okay, that is a good first step. Now, what we want is to have the include globs and then the exclude globs as the glob sets. And so all of this here is kind of useless to us. We're not going to do our own things. We want to change it with an option of glob set. So the way we're doing that is like that. So we're going to take our include globs. We can shadow the variable because we don't need the previous one. So we're going to do a include globs, and we are mapping it with our get glob set function, which is this one. Because that will take a closure, whatever is in the sum. So that will be this one. That will return an option of a result of a glob set, which is that. Makes sense. But we don't want that. If this fail, we want to fail. So then after we can do a transpose, and that will swap the result with the option, which is exactly what we want. And then we can do a question mark, and then boom, we have our option of glob set. And if we fail, if that fails, which is okay. And then otherwise we have the option, which is fine because it could be none and we have to know if it's none or not. So now that we have that, we can do the same thing for the exclude globs. And then that's it. Press save, everything compiles. So now we have those two, which is the option of glob set, which is perfect. Everything is clean for the next step. Okay, so that section is determine recursive def, and then this one is prep globs. And then we're going to have another section, which will be our build file iterator, our workdir iterator. So this one is going to be the big one. So let's go down to this guy. And so here's the way we're going to do it. Let workdir, and I'm going to put it as iterator. So I don't always do that, but in this case, I want to make it explicit. So I'm using this notation. Obviously use what makes sense. It's going to be our workdir that we need to import for workdir. The way it works is you do a new, and we're going to give our dir. So that is a new dir, it returns a workdir. And then we can customize it. So we can look at the doc, or again, sometime I just go there and I look at the option. If it's well done, you have the option there. And then I'm going to say, okay, there's a max def over there. And if it's a builder, there's probably, and then I can see that that's kind of a builder pattern. So now I'm going to say, okay, there's probably a max def. So that is a way that I work usually because I'm lazy. And I do have Copilot, but Copilot on libs is not that good sometimes, except it's relatively old libs. So I still have to navigate things away. But sometimes it's pretty good as well because it does some fuzzy matching or whatever. So we're going to do a max test, yep. And that will be what we have, the def. And then we're going to have into iter, because it's fine, we can consume whatever it sends us, yeah, there's no reason. So that will return into iter kind of things. And then if you look at the doc, there's this filter entry, which we can use that allows us to filter an entry. And there's a little trick here that I'm using. So I do filter entry, and that will be a closure, and often I toggle the inlays, and that will be a dir entry of workdir. So it's not a directory, it's a dir entry, which could be a file or could be a directory. So now what we want, and if we option click to this one, we're going to see some example over there, and then basically it's a predicate. So you have to return true or false. So far, so good. So what we want is to have two things. And that is a little trick I got caught up at some point. If we want to filter the folders to not go down .git or something like that, we cannot use the files include or exclude globs because otherwise it will never be a file. So it will never match whatever extension if we had an extension. So that's why we had our base dir exclude. That is another glob. So we're going to do a if file type is dir. And here we're going to return if it doesn't match the path. Yeah, so we have e.path return the path. So if the exclude does not match the path, we're good. If it does, then it should return false. So that's why we have the is match and we have the not over there. So that is for the folder business. And then after we have if file, we apply the globs. And then we have two globs to apply. Yeah, we have the include and the exclude. So we're going to do else. So we can say else, and if dir, check the dir, exclude. There might be a different way of doing that, but it works pretty nicely. And then on this one, we're going to do a if let sum exclude. We're going to do the exclude globs equal globs as ref. And the reason why we want that is because we want to have a reference of glob set, because we don't want to take ownership, because we are within a loop here. And then in this case, we're going to compare it with our exclude globs, which now is a glob set, and we can just do is match e.path. So now if that match, we need to abort and just return false. If that doesn't match, if this two if doesn't go, then we're going to do the other one, which is otherwise evaluate the include. Yeah? So this one is first evaluate the exclude. We return only if we have a match. And this is not a simple else because we need to have those two running. So if we are there, this means that we didn't return early. Then that will be a match include globs as ref And here I'm using the match notation. You can use the notation you like, and that will be a globes. The formatting is a little bit off when it's autocomplete. And then we do a globes.isMatch in a path. So if we have a globe, thanks, otherwise it's always true. Okay, so what we did here is that we allowed the walkDir to filter the entries that we don't want to worry about. So the type here is not yet what we want. It's kind of this filter entry and everything. So what we want is to do a filter map. So we're going to do filter map. We're going to take the entry. And so now the entry is going to be a result. And so what we're going to do in the entry is we're going to do OK. And filter map means that if it's none, then it will filter out. And if it's OK, then it will take whatever the closure returns. So we're using the OK to turn the result into an option, such as if there is an error, we don't really care, it's going to be a none, so it's going to be ignored. And then we're going to filter. So we're going to use a filter of option, which now is going to return a dir entry. And now we're going to have the E file type is file. So I don't know if it matters to do this file type, rather to do this file. My hope is that if you do a list dir in some operating system, since we already have the file type there, it might avoid to do a system call. So that's why I'm doing that. I'm not really sure. It doesn't really matter at this stage, but that's just one thing I'm doing. Press save and everything should be pretty nice. So now if I toggle the inlays, we have an iterator of dir entry, which is exactly what we wanted. So it has been filtered over there, and then we had our filter map. By the way, here, just to explain the filter, because there's a lot of filters everywhere. This one, the filter is a filter on option. So the type that we have here is an option. And the filter on option, what it does is to say, if this function returns true, whatever is in is okay. But if it returns false, then none will be returned. Yeah? So first we were removing the error, and then again, we call filters. And if that returns false, filter will return none. And if that returns true, filters will return whatever is there. Yeah? Some of this, of the entry. That is what we wanted here. And this is why then we get this clean little dir entry over there. So this is quite a bit, but it's actually pretty cool to understand how things fit together. And now we can do a let path. That will be our path, what we're going to return. We're going to do a walkDir iterator. And we don't want the entry, we want path buff. So we're going to do a map E, which is going to be our dir entry. And then we're going to return E into path. And that should return an iterator of path buff, which was what we wanted. And now we can do our OK path collect. And we could put like turbofish over there, but we don't need to because the compiler knows what we want to collect to. Because if we go back to our function, he knows that we want to collect to vector path buff, and it just happened that he has a path of path buff, so he can do his job. And then everything works nicely. So that was quite a bit of work, but it's actually a pretty cool function, and there's many different concepts, so that was actually fun, at least for me. Okay, so since we are still in our files, there's a couple of utils here that I like to do, and I'm going to implement them. So the first one is a get reader. So we're going to see that we're going to bundle these files, so we're going to use buff reader, is a good one. And again, I like to wrap it, such as I have my own error here of the application crate, and then I make sure that I say which file has a problem when it's not found. So that is one thing that is always nice. And then we just return the buffer. That is one that I like to wrap. And then the other one, it's kind of a trivial as well, but it's a read to string. So that is one that just read from a file and then output a string. Is basically a very simple wrapper on top of this one. Two benefits on this one again. We're using our error, and then we're making sure that we're returning the file name here of what is not found. So that is quite helpful. Press save. We're going to have to do some imports. Again, we don't need, but again, if you feel more comfortable to use the Tokyo files, it's completely fine. Those kind of things doesn't really matter at scale. So now we have that. It's pretty good. So we have our files utils. So that is at the file. We have our dir utils. That is for dir. And then we have another one, and that is our file parser and rider. So that is basically what are going to allow us to read from 2ML and save to JSON and all of these kind of things. So again, we're going to make it very simple over here. So the first one we're going to use to read our 2ML, which is our body 2ML, it's going to be this function. It's going to be very trivial. And again, you can put this code in your code if you want. That is just my strategy, but there's many ways to skin the cat. So I like to have the load from 2ML. I want it as generic as possible, obviously. So it will just return a T, and then the requirement on T is that it can be deserializable. And then we're going to use our own read to string that we had below. We're giving the file as ref. So in this case, I could have said, and that would have been fine, I could have said path like that, but it's a little bit more flexible to have the import as ref of path. Either way works. This one, it's a little bit more flexible. You can pass buff or anything to it. So I have it like that. And then in the read to string, I was okay to just have path, but either way kind of work. And then you have the OK, and then we're just calling out 2ML from string content. So in this case, we read everything in memory, and then we are parsing with the 2ML. That is one that we have. And then the other one that we're going to use as well is going to be our load from JSON. And the reason why is in our .body over there, we are going to store the conv.json. So one thing that I like sometimes before having SQLite or SerialDB or whatever, just using JSON files to store, and it goes a long way, and it's structured anyway. And then eventually, if I want to get fancier, I can have SQLite. So we're going to load from our JSON and also write to JSON. And so very similar to what we have over there, we are reading, but this time the CDJSON has reader, so we can read from a buffer. So often that is more efficient. So that's why I have the get reader below. And so we're going to use the CDJSON from reader. Again, here it doesn't really matter. The things are going to be so small that either way, it doesn't really matter. Probably in just one block anyway. So that is going to be our load. And then what we're going to have is our save to JSON. And so that is going to be important as well. So again, on the file side, I'm being flexible here. I can take anything. And then on data, I take anything that can be obviously serializable. So if it implements serialize of CRD, I can take it. And then I get the file as ref because we have the import as ref. And then I can create the file. If I cannot create the file for whatever reason, I give the file and the cause. And then I just call the CRD writer. And in this case, I actually do the pretty because in our case is I want it to be convenient and easy to read. If I really wanted to save space or whatever, I will do a to writer only. That will work as well. But otherwise, we do this one. And that's it. So that is actually pretty cool because now we can read our 2ML, we can load our JSON, we can save our JSON, just a one-liner, everything is super simple, and it has our error. So again, one strong recommendation, and it's good for other languages as well, but wrapping other libs or other things is often good. Shouldn't go to the extreme either, but that is a good example of some good values. Okay, so now what we're going to do is the last step of our files, and that is going to be our file bundler. And the goal of this function will be to bundle to file. It will take a files, like a vector of path_buff, and then our destination file, which will be a path. And it will return a result of void, meaning that it won't fail if everything is okay. And we put our to do. Okay, so the first things we are going to do is create our writer buffer, because what we don't want is to load everything in memory and then write all at once, because that wouldn't be appropriate here because we might have quite a bit of files. So we're going to have mute writer, and that would be our buff writer from the standard library. And we're going to do a file create. Here we could have some handling of errors to display the file name, but typically that wouldn't fail because it will override it anyway. So now we are going to do a for files in files. So our file will be the path_buff, which is what we want. We don't have to do into inter in this case. Let's scroll down. So first we're going to check if the file exists and it's a file. If not, we're going to return an error. Then we're going to build our buff reader. That is again to have the symmetry with the buff writer, and even each file we are going to read them in a buffer. So even if it's a huge files, it won't eat too much memory. And then we're going to write to the writer, which means the bundle, this file delimiter. And then we're going to give our file path, and the file toString lossy will be enough. But in this case, it doesn't really matter because we just want to have a name for display purposes. So it's perfectly fine. Now, if we press save, that should complain because we need a trait in scope, and somehow the fix doesn't work sometime. So what we want to add, sometimes I do that, such as I don't lose where I am. I open the new stuff, and we want to add this one, the right. So that is a trait, the trait right. Okay. So now we're writing that, and now we need to write the content of the file. So then what we do is we do a for line of the reader lines. So that is the way it works. And then we're going to let the line to make sure this one, I think, also needs to have the buff read. We can do as underscore, and that will return us a result of a string, but we want the string. And if we cannot read, it's okay to fail. So that is, we have the question mark. We're going to do like that. And then we're going to write it to the writer and just a line, nothing else. And we do the write ln, so it will do a new line. So we are not changing anything there. And then at the end, we want to do the write ln with the writer. And that is because it's the end of the file, we're going to do 2 new lines. So that is just me right now. This could be changed later. It doesn't really matter. And then at the end of the loop, to make sure that everything is flush, I do a writer flush. I'm not really sure if that is strictly needed. I'm just doing it to make sure that everything is fine and printed. And then I do a OK like that. I might do a writer flush as well at the end of every file, but right now that will work fine. Okay, so that was pretty long, but now we have our cool file utilities for our application, and that will help a lot everything. So we're going to do one more thing now on the utils front, and that is for our command line, the nice prompt and the colors. So what we see here in the final product is we have the little check mark here in green, and then we have the question mark and the nice text over there. And then if we say, what is the best language, it turns greens. We have the little things here, which we already have, but then we have this little arrow, and then the text in white and so on. So all of that is a cool crates that we have in our cargo to ML, and that is these 2 guys here that allow us to do all these kind of things. And again, rather to have this code within our body or main or whatever, I like to have a util that manage whatever I need. No more, no less. So if I go to mode and I'm going to create pub mode CLI, not being creative on this one, and a CLI will be enough for now, just a simple file. And if I go there, we're going to do a couple of things. So first, we're going to use our create result, like always. And then we're going to create our first function, which is going to be for the prompts. And that will be a pub fn prompt. And we want to make it as simple for our application as possible. So we're going to have a text, going to take a str, and it's going to return a result of string. So very simple. We're going to do our to-do for now. By the way, I want to make sure that I don't have any to-do left. No, that's good. So I do that sometime to make sure. And then we're going to do the simpler way. And the way it works here with the dialogger and so on is this way. You do a let input, and you have an input with theme. And right now, so we need to import this, and we're going to have a color theme. We're going to import that, and it should have a default, I think. And then if we go back here, we do a command ki to get some information. So I don't like to have mouse over and things popping up. I like to trigger them. So this one take a reference of a Dean theme. So we're going to have something like that, and that should work. Now, this one doesn't work because what it's going to tell us is it doesn't know a type, because we didn't say was string or whatever, but that is going to be solved lower. So the way we do that is we do let res, and we do an input with prompt, and we're going to give our text. And this function, interact text, and something like that. And now what we can do is we can take this one. So now this, again, doesn't know, but we can take this one and we can do a OK res, and that should fix most of our things. And so this one doesn't work actually, because the way it works is that it's going to be dropped. Typical things in Rust is fine. We're going to have themes like that, and we're going to have our let theme, and then we do like that, and then everything works. Now, we can actually do a little bit cooler, and for me, if you look at the color scheme, you have all of these things that you can customize. And to know how to customize them, if you go down to the source, this is a default. So the code is pretty nice on this one. They show you exactly what we want. So what I did is I went through that, and I say, well, I want to customize it a little bit. And then this is what I came up with. Obviously, come up with your own. So I just copy paste the default. I tune it for whatever I wanted. I need to do the import here. And then boom, I have exactly what I wanted. Rust is pretty awesome. Because everything is open source, you can go and look at the source, you see the properties, and this one are kind of cryptic, but we're lucky because we have the default. And then we learn the APIs like that. It actually makes a lot of sense, the way they've done it. So pretty smart. And then we have our little prompt exactly the way we want it. So that is for our prompt. Now, one other thing, we're going to have this little check mark here, and I'm going to call them icons, even if we're on a terminal. And so there's a way with console and everything to create those. And rather to have this code everywhere spread out into our code base, we are going to actually create a new code region here, and that will be for icons. So we're in a world of terminal, obviously, so that won't be images. But for example, for our check, the way it works is like that. We will have a function that is echo check. It will return a style of object, and that could be static str. So that's why here we're not using the same, because this one has to be a own value. In our case, most of the time we can have static string for these icons. So that will be style this one and in green. And it will encode the things the right way, such as the terminals will understand what it means. And so now that we had that, we can create many of them. So for example, we're going to have our icon for uploading. Once we upload, so the icon will be yellow. And then when it's uploaded, same icon in green. Do whatever makes sense for you. And then we're going to have our deleted icon. So that is not an error, it's more something has been deleted. So we're going to have the deleted icon, but with green. And all of those are Unicode, so you can find it on the internet and copy paste and put them there. And then the last one will be the ICO error, and that will be a little cross, and we're going to put it in red. So again, if we want to have more icons, we put them there, and everything is kind of clean and well ordered. And then we can change them in one place, and then everything will be good. Now, the last step is going to be our text output. And so that is when we're printing kind of things. And sometimes when you put this color, the color stays for the next println. So you want to make sure that usually when you print, you kind of reset the things. So what we're going to do in our text output, we're just going to have one right now, txt rather than icon, res, which is response or result or whatever, and just the text. For now, we just have the default and bright. That will be good enough. So again, this is some best practices that I've learned that if you do them early, then the velocity of adding features is much faster. And in fact, even more fun. So now we have everything we need, and we can go back to our body, mod.rs, and we're going to do our public functions now. So let's scroll down. So the first function we're going to add is going to be our name, and that will just return the self-config.name, a reference of it. So that will be simple, because if we want to display it or whatever. Then the next one, and that is going to be the big one, is going to be our async fn init from dir. This is the one that is going to init or load all of the constructs that we need to have. And it will return a result of self. That will be the goal of this function. And what it will take, it would be a dir. We're doing import as ref path. And then the things that we're going to have as a flag as well is a recreate assistant, and that will be a Boolean. So basically, do we want to recreate the assistant or do we want to load? So that will be one of the commands will be to reload everything. We're going to import that. And now we can scroll down to this function. Okay, so now we're going to get our dir as a path. And then we're going to load from the directory. So now we have done all of these utilities. So it's just one line. So it's very nice. This is probably something we need to import. Now, what we want is to get or create our OpenAI assistant. So first we're going to get the new client, and then we're going to load or create the assistant. And here we're giving our config into. The into, the from is for reference of config. So that's why we need to do that, to make sure that the into get the reference of config. And then we are passing the recreate assistant. And that will return us an assistant ID. So we press save. We're going to have some import to do. This one, and then this one, which is just the module. So in this case, I like to have the module like that, and actually this one is not. That code is this one. So that is a way that I like it. When we call the module assistant, we have the prefix like that. So I don't do that for every module, but this one is big enough, and it kind of makes sense within this context. And now we have enough to create our body. So to create the body, we just take the dir, we want the path buff, the client, the OpenAI client, the assistant ID, and the config. This way, we have the body now. So one thing we're going to do as part of the init of the body will be to upload the instructions, and that will just be like that, upload instructions. Then we're going to have to do our upload files. We have more things to do over there, so we're going to fix me upload files. Actually, technically, that is a to-do because it can work without it. And then we're at the end. We can do a OK body. We might not have done this one actually, so we're going to do that. So let's implement our upload instructions. This is a very good next step, and that will be a pub async fn upload instructions. Let's see if our Copilot can get it. I'm using Copilot carefully because sometimes it gets that, but sometimes it takes more time to debug what it does, and so it's still work in progress on this guy. So no, it doesn't work. It's not the config instructions. We have instruction files. We need to load the files. So again, yeah. And we're going to return a bool, which is going to be the boolean of did we upload it or was it already uploaded? So the first thing we're going to do is get our files for the instructions. And so that will be our dir, and we'll do a join, and then we'll get the instruction files. And so that will return a path buff. Now, what we're going to do is we're going to have two branches. One, which is if the file exists, we'll do some work. And if it doesn't exist, we're going to do a OK false. That will be the strategy of this function. So first we get the instruction content, and we do the file to read. It's actually here, that's my mistake. We should do our own guy. We work very hard for it. And then we're giving a reference of pathbuff. So that will read the file, and that is because it takes a reference of path. If I would have done it with the asref of pathbuff, then I could have done the pathbuff there, but that works fine. And now we can just upload the instruction with our assistant upload instructions. That is what we have done. We're going to do the println, and here we're going to have our cool little check over there. And then finally, if everything good, we return true. And on this one, we're going to return false. Save, import this one, and then we have our clean upload instructions. So next, what we want is to create our conversation and save it such as we don't have to recreate a new thread every time we do our cargo watch, every time it reruns again, because otherwise it will be confusing. So the way we are going to do that is inside our body folder, we will have a file which is our conv.json, which will be just a serialization of our conv object. And if we click on it, there's only one property there, which is a thread ID. And then we load that and we write that when we create a new one. So that is going to be the way it works. And when we are going to do our bundle files, it will be below the .body files. And this folder can be deleted, and then things will get recreated except the assistant, which is a lookup by name. Okay, so to do that, we are going to close this one and create a new function, which will be our pub async. And we're going to call it load or create conv. Take a self, and it will also take our recreate, which is in this case, recreate the conversation. And it will return a result of conv. So far, so good. So we are going to go down to this function. The first thing we are going to do is we are going to get our conv file from the data dir. So that is why we have the data dir before. So that will create it if it's not there, and then it will return the pathbuff of this file. Now, if it's recreate true and the conv file exists, then we can remove the file. In this case, we could have wrapped this one, but I'm using that guy for now. And that is a standard FS. And that will remove the file if it already exists, if we have the recreate. So this way, the logic below can just care about if the file is there or not. And now what we're going to do is we're going to get our conversation, and it's going to be two cases. One, if we have a conversation in our load from JSON, and we're going to give our conf file. And here we need to help a little bit because it cannot guess, obviously, that we want a conversation back, because that is what we have here. And it could at the end, but right now we're going to do that. So that will return a conversation if it could parse one over there. So if everything works, what we're going to do is we're going to get our threads, the OpenAI client, the thread ID, and then we're going to await. And if it's not found, we're going to reformat to say that we couldn't find it. We're just doing a print debug here. Now, if everything is okay, we will print conversation loaded to make sure that we didn't create it, and we're going to return our conversation. So this way, this one will be our conversation. And then else, so if that return an error, so the file is not there or something like that, so we don't really care why, but if it's not there, then we're going to create it. And so to create it, we're going to first call our assistant, create thread, that will return a thread ID, and then we're going to say that the conversation has been created with our nice little icon. Then we're going to get our conversation from the thread. So we have the into, so that works nicely. So that will return a conversation, and then we can save the conversation into the file. So that is, we have the save to JSON file. Press save. We probably have an import to do here. And that is because that doesn't return the conversation. So we need to conv here. And that is a statement because it's an assignment there. So we need to make sure that that returns the value. So it will return the conv in both cases. This one is a new one, and this one was already done in the file. And that's it. So that will return that. We don't forget to change our to-do. Okay, conv, and then that's it. So we'll have the load or create. There's probably something we can do a little bit nicer here if the file cannot be parsed or whatever, but that's good enough for now. And now we're ready to do our chat, which is actually the simplest of all. And that will be a pub async fn chat will be our self. We'll have the conversation because we chat on a conversation, and we'll have the message. So that will return a result of string. And this one is so simple that we can do it without anything. So we do a res, and that will be our assistant, will be our run thread message, the self OAC, the self assistant ID, our conversation thread ID, because again, our assistant doesn't know about conversation, just know about thread ID and our message, and that is what we had. And then we're going to do a await question mark. You should reformat it like that. Press save, and everything compiles. So now we should be able to go back to our main and do that. And then the only thing that we're missing in our body is a whole file business, uploading and deleting. And that is actually quite a bit of work because if you refresh it, you need to make sure you delete it and so on. But we're going to do that later. For now, we're just going to chat with it. So we're going to go to our main and we're going to do some changes over there. And that is not needed. So we're going to delete, go back to square one, even this one here. So first we're going to have a little const here. We're going to put it below the start. We're making a little exception here. The main is something that we run and will bootstrap the thing, but everything will be there and that could move to another file one of these days. Because in fact, what we really want to do is to have an event base or something like that, such as something is listening to events and then just answering, such as then we can scale it up. But for now, this is good enough. And then we're going to have a cool thing and we're going to prep the future here with a little types. And in our types, we are going to have our input command from the user. And the way it will work, we'll have our on command. So that is our command. And we'll have the quit. We'll have the chat with a string. So when the user says something, we're going to make it that enum. And so like this, our loop will loop and we'll parse it, and then we'll do a match on those guys. So we do a refresh. We will have a refresh all, that refresh the whole assistant, everything. We'll have the refresh conversation only, refresh the instructions only, and then refresh the files. This way we have this little enum, and we need to write the parser for it. Obviously, we could implement the from str, or we can just do implement cmd, and then we have a fn from input, and then we're going to make that a little bit flexible. And the reason why I'm doing that and not a reference of str is because when I'm going to get it there, I want to own it. So the nice thing about this strategy is true that the compiler might create two different functions, one with reference of str, one with string and everything. But the benefit is that when we do an into, it won't clone it. If someone gives us a string, it won't clone it. If someone does give us a reference of a string or a reference of a str, then it will be a toString. But if someone gives us a string, there's no clone involved. That's why I use implement into string. Then that will return just a self. The reason why it's self and there's no error, because if it's just a string, it goes to just string. We could have a result of self. In case someone is giving us a command, we know that it starts with slash and is not a valid command. That might be a good case, but for now, that will do. So we always need to shadow this one to make sure that we get the into string. Good to do for now. And now we can implement this one, and that is going to be trivial. And long story short, that will be the one we have. So if we have /q, that is quit, that is refresh all, /ri, instruction, /rf, or rc. Added the slash, we could do the backslash as well. We could do both if we wanted to. And then if it's none of those guys, then we'll do a input to string here, which actually does not need to be input to string, just input. And then that's it. So now we have these things, which is pretty cool. So the first thing we're going to do is init our body. So that is a function call we're going to give with our default dir that we have, and force because we don't want to recreate at this time. And then we're going to load our conversation or create it. And again, here we don't want to recreate it, and that will give us our conversation. So if we press save, that should compile. We need to import the body. And then what I typically do is something like that. We'll do body, and we're going to do the name over there. So like this, doesn't take too much space. And then conversation. And then this one, we can do the debug. We'll do like that. That should compile. And the moment of truth is, and then I go that. Oh, that is pretty cool. It works like, so we do our conf. We have the things over there, and we don't create the files yet, but at least we have that. And if we go to our assistant, we should see that here. That should be the one that we just created. Oh, actually, we loaded it here, and we still don't have the check here. We're going to fix that. But we loaded it because I probably have one before. I'm going to delete this. And now if we do a cargo run, or we can do our cargo watch run. I'll do my alias over there. Okay, so there's a couple of things that are happening here. First, we don't print correctly if we create or not the assistant, so we're going to do that. And then second, here is kind of misleading, and it's not a bug in our thing per se, is the way that thread works. Thread is detached from an assistant. So we loaded this all one because we had the conf.json, so it loaded it. And it passes. So when we load, if we go to the body and we go and look at our load here, so we got the file was working, and we do a get threads. And even if we have deleted the assistant, a thread in the OpenAI API data model does not belong to an assistant. Get attached to it to run, but it doesn't belong to it. Meaning that when we delete the assistant, the thread still exists. Now, if we were going to try to chat with it, depending on how things work, it might work or not, or it might be confusing because it will be a conversation of before. So that we're going to fix this kind of thing. So the first thing we want to fix is a print of the create. So it's nice here. We know that we have uploaded the instructions. We know that we have loaded the conversation. We haven't created it. We don't know what is going on with the assistant. And that was because it was before we had our thing. So it's in our assistant, load or create, and it's returning an assistant ID. So over there, Eventually, we want to refine and refactor the way of who is writing what to where in the console or not. Those will probably be more event-based, but right now that will work pretty fine. So we're going to have a nice little icon over there, which will be echo. I think we have a deleted OK. That will be nice. And then we need to print here. So the things that we're missing is here when we create it. So we're going to have an icon over there, and that will be our check. And we're going to take that, and we're going to do it after and create it. Okay, so the create take ownership. Oh, okay, so this is why I had the assistant name there. So this way, at least we take the ownership and then we just clone the name. So now we're going to print that, which is nice. And so if we go back to our thing, oh, that's it. So we have our assistant loaded, instruction loaded, conversation loaded. Okay, so we're not prompting yet to start the chat, but now things are doing pretty good. So let's go back to our main, and that is what we printed over there. And so now we can do our loop. What we want to do is a loop, and we're going to do a spacer. And now we have our little input, and that will be our prompt we built before. And ask away, question mark. And then we're going to have our command in a way, that will be our command. And that will be our command from, by the way, here to have our little debug here. And now we're going to match our command. We're not going to implement everything. We're going to implement the quit. That is going to be super simple because it's going to be a break. And then we're going to implement our chat. Take the message. And on this one is going to be that simple again. We're going to take our result from our body chat. We're giving our conversation. We are making it mute because later we might refresh it. That's why. Otherwise, I like to make things not mute. But in this case, we need to have the mute. And then we give our message and wait. And then we're going to have a less result. We're going to shadow it. And that is the next one, which is a very nice little crate. And that is this one here. This one is awesome, text wrap. There's some very good developers in Rust. And then this one is super cool because we do wrap and we give our text. We give our 80. So that is a number of characters we want. That will give us a vector of core, whatever. And then since Rust, I don't know which version, we can do a join and boom. Then we have a string, super cool. And that will be println. And this little detail make the chat much nicer because otherwise it's hard to read across the whole width of the window. And then we're going to have our little icon and then the response. That will be our echo result or response. And that will be our text or txt result. And I like symmetry. So, and then this one somehow doesn't work. So let's go there. We might have missed it. Oh, I didn't put it in. My mistake. We're going to put it there. Close it, import, done. So now we have that. Rust tells us, hey, you didn't do everything. We say, we know. So we're going to say println, and we can do a nice, again, little icon, command not supported, and we'll do the debug mode. That should be able to work. Oh, we forgot our. So that should be pretty neat now. By the way, every time I press save, I think he did this business. Yeah, he did. And then that's pretty good. Should we try it? It's a little bit scary here. So we're going to say, what is the best language? Oh, that is so cool. Second best. Boom. And it's cool because that is all the round trips that we do. So sometimes it goes pretty long. Sometimes the API goes pretty long. So that is pretty cool. Okay, so we're going to do quit and boom. Bye. So I think we're on a stage here where we don't need this debug print anymore. And this is a very good stage already. So now we're going to do the rest, the refresh, conversation, and the bundle and everything. So for that, before adding the bundle and everything in our body, we need to make sure that our assistant, which is a lower level API, supports files. So if we go back there, we have our constants, we have our types, we even have a file ID here, which was in preparation. We have our assistant CRUD, our threads, but we don't have anything about files. So that is what we're going to create right now. So the function we're going to create is going to be like that. Pub async fn and upload file by name. Because what we want to do is that if the file name is already uploaded, we want to have an option to say we don't want to upload it. So we're going to take the client, the assistant ID, then that will be the file, and the file name will be the file name of the file. And very important here, the assistant does not know anything about bundle or whatever. The only thing it knows is that it's asked to upload a file to OpenAI for that assistant. And the way it works is that you have to upload it first in the org file. So that is the files, and that is all our files. So here I already uploaded it, but we can delete it later. And then in our assistant, this one, for example, we want to attach those files. So that is the way it works with OpenAI. You first upload it to the organization, to your account, and then you attach it to your assistant. That is the way it works. So for that, this one will do both. It will check what is there, and then it will upload it. But we also have a flag, which is our force, which is even if it's already there, we want to delete it and re-upload it because it's a new one. So this way, at this level, we're going to be quite flexible, and then the body will decide what to do. And it will return a result. And because we don't want to lose information, it will return the file ID. So that is our file ID with a string from OpenAI, but also the Boolean to tell if the file has been uploaded or if it was already there. So like that, the caller will have the information and then it can decide what to do with it. And for now, we're going to do a to-do. Now, there's a trick, unfortunately. So if we look at our API, we're going to do the API is over there and API reference. So here's a trick. If we go to our assistant and we go to our list assistant files, that is what we need. Now, the trick here is when we get the list of files for an assistant, and the async OpenAI is just a mirror of this API. It's pretty good. But the problem is the OpenAI API does not give us the file name. And because we want to map it with a file name and not to have another files where we store the states and so on, it's tricky because we cannot get it from there. So what we need to do is to do a query of our files first, and then we get the file name. And once we have the file name, we're going to map it to reduce it with the files from our assistant, this assistant files. So we'll get that. It's the same ID, so that's the good news. And then we'll make sure to just get that. So that's the function we need to write. It's actually a pretty cool stuff to write in Rust. We're going to do it before. And then we're going to call it get files hash map. It could be a little bit clearer on the name, but that's fine. OAC or OA client. And then we have our assistant. That will be our reference of assistant ID. And what that will return will be a result of hash map of the file name and file ID. So basically it will be file ID by the file name. So that will be the goal of this function. And because that is not super clear what is a hash map of, now what we're going to do is do a little documentation. Returns the file ID by file name hash map. Okay, so that's my command strategy. If the code is descriptive, it's fine. Otherwise, we add the comment. So now let's scroll down to this one. And then this one is actually pretty fun to write in Rust. So we're going to get all the IST files, which is files that do not have the .name. So that is the first things we get. We get all of the assistant files for the assistant given, and then we'll get the full list, and then we'll reduce it. So we're going to have our let OA assistant files. So that is kind of the manager. So it's OAC assistants, and then files, and then we're going to give our assistant ID. That will return an assistant files. And again, that is a controller, the thing that we can call function to. And then we are going to get our files. So we're going to let, and that will be the assistant files. So my convention is when I don't prefix it with OA is the real data. So I do the OA, assistant files. I'm going to do the list, the default query, which is 100. So we'll have to think about that later. And we do the await and the data. That will return a vector of assistant file object. Now, what we want is we want that when we get all of the files for the org, for the account, we want to make sure that the ID is there. So we don't want to always have to loop through the vector. So what we're going to do is create a hash set. So it will be an assistant file IDs. That will be the type of hash set of string. We don't need to do the file ID there. So that will be the string, which is a file.id from OpenAI. And to create that, actually putting it in Rust, we do our assistant files. We do the into iter, because we can consume it. Map, that will give us a closure. That will be our file assistant object. It's not a reference because we did the into iter. And now we're just going to do a f.id. And that will change our file to the string ID. And then we do the collect. And the compiler has enough here. I'm going to import this one. And that is one of this drop business here. Yeah, that is. So, and now that works nicely because the compiler knows that he needs to collect into a string. And because this one implements everything that a hash sets need to implement, because that is just a string, everything works nicely. So now we can get all files for org, and those files have .name, which is actually .file name. And for that is super simple. We do the let OA files, oac.files. So that again, it's the controller, and then we do a org files. I call them org files, and then it's OA files list. This one, as of now, doesn't have a query. Eventually it might have, I don't know. But anyway, the OpenAI API doesn't have much. You can put in a query, so it's fine. And we do a await and data. And that will return a vector of OpenAI files. So we see the difference here. The async OpenAI lib is pretty cool because it's actually two different types. Yeah, this one is the assistant file object, and this one is the OpenAI file object. And in the docs, they don't really make the difference. They actually link to the file, which is actually not the case. So anyway, so we have the right type. And so in this one, we have the file name, and the one above, we don't have it. Now what we can do is build our file name, file ID hash map. Yeah. We're going to call it file ID by name and hash map string file ID. So often when I do the collect, you could put the type as turbofish over there, like something like that. That should work, but I like turbofish for some of the things, but usually when I collect like that, I do this way. It's more readable for me. But again, that is a personal or team preference. Just follow what works for you and your team. So now we do a org files. We're going to do the into there. So we're going to go through all of the files. We can consume it, so we don't need to clone or anything. And now we are going to filter, and let's scroll down a little bit here. We're going to filter, and what we're going to get here is the org file. So because we have file everywhere, I'm going to prefix it with org. So in this case, for example, is a good example where I don't have only one letter because, there's file everywhere, so we wouldn't know which F it is. I say org file, that is my OpenAI file. And now I'm going to check my IST file IDs. Let's scroll down too far, which is this one. Yeah, the hash set that we have there. And we're going to contain the org file.id. At this point, we don't want to take it out, obviously, so we take the reference. And that will tell us if the org file ID is in the assistant IDs hash set. And if it returns true, it will be kept. And then we want to map it. Then again, that will give us the org file, which is the OpenAI file. And because we did an into here, so the filter get a reference because we don't want to consume it here. So the API is right. And because we did an into here, we get the org file, which is good because we just want to return something that can be collected into the hash map. And The good thing is a tuple of org file.file name, that is a string, and org file.id, that is a string as well. And we're going to do an into because we want our file ID type. And the cool thing about Rust is once we start to code the right way, everything is super productive. We do a collect. And now if we press save, that should work. And the way it knows that the into is for file ID, because we did a collect and they do the magic or the power or whatever we want to call it. And then boom, they go back and they know that is the into of file ID that it needs. And so when we get a tuple like that, which is that as a tuple, we do the collect, it will do the hash map. And now we just need to do a OK file ID by name. And that's it. It's pretty cool. I actually like it a lot. So that will give us the get files hash map. And so now we are all equipped to do our upload file by name. So let's go down. So first, let's be very clear about what we want this function to do. So this function is about uploads a file to an assistant. And what it does is first to the account, to the org, and then attaches to assistant. And then when we have false, is false will not upload. For upload the file if already uploaded. And then if we have the false is true, it will delete existing file, org, account, and assistant, and upload. And it will return something like that, which is going to be the tuple of the file ID, and the Boolean is going to be has been uploaded. Okay, so if it's a new one. So I'm going to have this notation, eventually I can make it fancier. So I'm trying to be concise, but informative, but have the style that works for you. So that would be our function. The first thing that we need to do is to get the file name. So we need to do a let file name equal file, and then we have the file name. But file name return an option of OSTR and everything, and it's always kind of a little bit tricky to work with all of that. So one thing that I like to do is I go to my files, and you guessed it, here I have my file utils and everything. I'm going to create another section actually, and I'm going to create for X file. That is for the oldies, and that will be a trait. And the goal of that is all of these things that I always need to do a map and everything and all of that, I can have my own function that I want. And I like to have the X prefix, and then I do fn X file name, and that take a self, and that will always return a reference of str. And so that reference will have the same lifetime as this one, or a bigger one, but at least the same as self. And the goal of this is traits that has methods that returns the str when okay, and when none or error returns empty, static empty. So that is just one strategy that I have. Eventually, I might have something like that where I put that under a result if I want to. But at least my strategy would be to say, we're going to have that, and also something for the extensions. We might need that later, and that will return str with my strategy for now. That I might change it over time. I don't have to be perfect in this strategy. The point is that I'm normalizing things for my app code, and then eventually I will fine-tune it to make sure that or I don't lose the important information. So now what we want to do is to implement that for path. So we'll do implement xfile for path. And it could have been xpath, it doesn't really matter. Xfiles is better, it's cooler. And then we have these two methods. And that, for example, on this one, this is where we're going to put the whole file name and then to str, and then we're going to unwrap to our static string. We need to import that. And so the nice thing now is that every time we do x file name, and that will return a str, and our strategy today is to say empty string, and it's fine. The reason why that works is because that is a reference, is a static reference. So that will live for the length of the program, from the time it has been created. And so that will live longer than this reference, which is bound to this one. Okay, so that is what we have here. This is the implicit lifetime that we have. So this one is fine. It doesn't break the rule because he lives longer anyway. So that is why that works nicely. And then for extension, we have a similar one here, which is we take the extension, we return a similar business, and we have the same strategy. So now we have that, and we can go back to our assistant, and rather to do that, we can do our X, and we should have our file name, and that will have a reference of string. And again, the trick here is empty if there's an error or if there's none. That is our strategy. We can change it later, but at least everything is normalized. So now what we're going to do is we're going to get our hash map, the one that we have the file ID by file name. And that will allow us to remove the file ID by the file name, if there is one. So that will return an option of file ID. The reason why we had to put that mute and we're using remove is because if we do a get, I mean, it will work, but that will return a reference of file ID. And then we'll have to clone it, or it's more complicated. And so if we do remove, then we get the option of file ID, which is what we want because we don't even need the hash map anymore. And then the first things that we're going to do after that is if we don't have the force, so we're not doing a force upload, and the file is already created, so it's already there for this file name, then we're going to return early. For that is, we need to do two in this case. If it's not force, then we do a let sum file ID, and then the file ID, which is an option. So that will get the file ID. And now we can return OK with our file ID. So this is why we wanted it on over there. And then we do false because we haven't uploaded it. So that was a contract. That will work pretty nicely. And then what we want to do is if we have an old file ID, we delete the file. So we want to make sure that if we are here, it's because we have a false and or we have a file ID. And so in this case, we want to delete it. So let's do that. So for that, what we're going to do is we're going to have the if let file ID. So to make sure that we have the file ID, because this one is an option, and we're going to need to do two things inside. That is important in the case of OpenAI. The first one is we need to delete the org file. So that is a real file in a way. So if we look at our data over there, that is what we had there. We need to delete whatever file we have there. Yeah? So that is a file that we need to delete. And then once we have deleted that, the second thing is we need to delete the association with the assistant. So the assistant file. That is the two things. Then after, once we deleted this guy, we're going to need to delete one of these guys. Yeah, the one for the file ID. Yeah. Oh, that's funny. In the UI, they show the file name. I'm not that nice in the API. Okay, so for that, we are going to do, and it's relatively simple, we're going to do a let OA files. So that again is our kind of files controller, OAC files. So that will be our files business. And we're going to delete it. And if there is an error, we don't want to fail, we just want to print it. Because sometimes the file might be deleted or whatever, so we don't want to make a big deal out of it either. So we're going to say if let error, we're going to have our error, and that will be OA files delete, and that is our file ID. We do the await. And so if we're on this block, it means that something was wrong when we were deleting it. We're going to assume that it was deleted somehow, and we're going to print something like that. So can delete, next line, a little bit of spacing, the cause, we do our nice little icon, and the string lossy, which is perfectly fine for that name. And then we have the error over there. So press save, make sure we import this guy, and then that will be good on that side. Yeah, so it's easy. This one we just did it, and if there's an error, we don't break everything. Now, on this side, it's not going to be that hard either. The assistant, OAC, dot assistant, yes, and then let OA files, and that will be our OA assistants dot files for our assistant ID. And that is already kind of a reference, so everything is good. So that's the way, and we need to do that because otherwise there's a too early drop over there. And then we're going to have the same strategy again as we have above. We don't want to break too much if things cannot be deleted. And again, this strategy can be revised, but always print. If something goes wrong, always at least print or trace, and then eventually we can have a different strategy. And that is cannot remove the assistant file. Yeah. So we press save. That was my old code here. So that is a way sometimes I do. It's a more generic way of doing my X file name and everything. So I put that in option and everything. But in our case, we didn't do that. We did, which I actually like it as well. We did this one. And it's not an error. You return a string, and then we press save. So that is what we have here, because this one returns str no matter what. So this one is actually pretty nice as well. So now we have done the cleanup. And so what we are going to do is upload and attach the file. So if we are here, we are ready to upload and attach the file. Okay, so first, what we're going to do is we're going to take our terminal, and that is a cool kind of console terminal, which is going to allow us to have better control on the terminal. And then we're going to print the uploading. That is the way it works. So in this case, we do the terminal, we do a write line, we're going to format, and that is because we want to have our little icon uploading, and then we just give our name of the file. And that again is not x2, is x file name. And that we're going to import that. So that will print, that will do a nice little print. And then we are going to upload the file. So to upload the file, we get the OA files, which is again the controller, and we're going to call it with a create. We're using the create files request. We're giving the file name, the file passbuff, I think it is. And let's import this one. And if we option click, that is a file input, okay? So there's a from file input to path, so that's why it works. And then we have the purpose, and do not forget to put that, and make sure to put a S over there, and that will upload the file. And we're uploading it to the org here. Yeah? And then we are going to update the print. So that is what the control I was talking about. Now we can clear the last line. So we're going to have the uploading, then we remove it, and then we're going to write a new one. So that's the way terminal works when we see the thing progressing. We just remove and then rewrite on top of it. And we're going to do say uploaded, and with the icon uploaded, which probably need to be imported. And then I'm sorry about that. And that should work very nicely. And now what we want is to attach file to assistant. And for that, we're going to get our OA assistants, our OA assistant files, and then we're going to create our file. And so that is to create the association, and we're just giving the file ID. So that is the way it works. Yeah? So we're giving the assistant ID over there to get the assistant files, and then we're giving that. And we're doing a clone because it has to have his own. We're cloning the string. And the reason of that is because I'm using OA later. We're going to do an assert later. And so if we press save, we just need to import that, and it should be fine. And then we're going to do a little assert. And it's not really an assert because it's not really going to fail in a way. It's just going to do a warning. And that is going to be if the org file didn't match the assistant file ID, then we have a big problem. It shouldn't happen. So I'm just printing it. Again, it shouldn't happen. But if it does, we might have a bug in our code or we did something wrong. So I'm just printing it. If we were tracing, I will do a debug or a warn or something like that. So that is optional. It's just me being a little bit paranoid. And now we're going to press save to make sure everything compiles. And we're going to do our OK. And we are going to need to have the file ID. So we can take either one in a way. So we're going to take this one, and we're going to do into. That will make it a file ID type, and then true, because we uploaded. And that is a tuple. So we make sure to do the OK of the tuple. Press save, and everything compiles. So that was quite a bit of work, but it's quite a bit of things as well. So we have our upload file by name. So now what we can do is go back to our body, and we are going to go to our public functions, and then we're going to create pub async fn. And this one is going to be not one by one, but we're going to upload everything. So we're going to say upload files. It's going to take self, and we're going to have the recreate boolean if we want to force upload. And then we have a result of use 32. That could be use 16 or whatever. And that will be the number of files that we have uploaded. This is completely optional. It's just, I did it just in case we wanted to print that somewhere, and we have the information. It's free anyway, so we're going to keep it. And so the first things we're going to do is let mute num uploaded equal to 0. Then we're going to get the body files folder. And for that, we're going to have let data files dir, and that will be something like that. And that should work. We're going to put the to-do here so that we have the things, and then something is wrong here. Okay, so now we have the path buff, which has been created if you need it. So the first thing that we're going to do is we're going to clean the folder if there were leftover of the old assistant ID. So it's going to become more clear. So the goal here is we are going to list all of the files inside our data files dir, and we are going to exclude anything that have our assistant ID. Because in fact, in our bundle files, we are going to put the assistant ID. So that will clean all of the old files that we had before. And right now we are hard coding, and we know that we have either star.rs or star.md. The correct way here will be to get it from the bundles and get all of the unique extensions, but so far I put them there. And then because our list files that we did before has the include and then the exclude glob, we're going to give the exclude like that. So that will give us all of the files that ends with .rs or .md, except the files that have the assistant ID inside. That is what we have there. And now we need to delete those files. So the goal again is to clean the old files that we have put. And that will be a folder that will be below our .buddy over there. So now the delete is going to be like that, where first we're going to get the file string, and we can get the lossy one. It doesn't really matter. And one thing that I like to do when I delete files or delete folders is to have some sort of safeguard. It can be just me, but I have a phobia of deleting files that I shouldn't be deleting or whatever. And in fact, on macOS and things, there's a thing that says to trash. So that might be good as well. But right now we're going to remove them. And I have this safeguard that say if it doesn't contain .buddy in the path, then we're going to return and break everything and say, we shouldn't have deleted this file. So typically that would be completely safe because the way it works. But in case there were a bug, at least we're checking that we have a .buddy in the file path somewhere. So that is what I like to do all the time. And then after we remove the file. So this way, we're going to clean up any files we might have inside our .buddy/files folder. Press save, should work. And now what we can do is generate and upload the .buddy files, bundle files. And the goal, and it's just for now, for just at the beginning actually, is to regenerate the files all the time, even if we don't re-upload them. And that is because we're early on the development, and sometimes it's nice if I want to change a format or whatever, I can just change it, see the files on my local, and then re-upload or whatever. So that is what we're going to do in this section. So what we're going to do is we're going to iterate through our file bundles, and we don't do an into iter, we do an iter because we want to have a reference of our bundle. And then the first thing that we're going to do is get our path buff from our dir. So again, everything is relative. The source dir is relative to the dir of the body, which is the dir of the body2ml. So the directory of this one, which is in this case body, and then we do a join here with our body. And then we do a if source dir is dir, so that would check that it exists, and that it is a directory. Then we're going to get our source globs as a vector of string. So that is to be able to pass it to our globs. So that is the things you need to do. You need to get the source globe. We do the iter, we do a asref, and we collect. That will give us a vector of reference of string, which then can be passed as a slice of reference of string. So that is the way it works. And then we do the list files that we have over there that we did before. And we give our source dir. We do not have any exclude in this case. And then we're just giving our source globe. So that is a slice here. So that will be a vector of string. And that will give us a slice of a vector of string, which is the same thing as that one, the reference of an array of string. So that will be what it will coalesce to. And then we're going to do a check here. We are going to do a files. So we're saying if it's not empty, and we're going to compute the bundle file name. So for that, our bundle file name will be the name of the body of the assistant, the bundle name, that is what we have in our body2ml over there, this one. Then the assistant, so that will get into a string. So that is what we want there. And then the bundle destination extension. So this way we have the self name for the human, for us, to be nice with us. We have the bundle name, such as we can find our duck. And then the assistant ID, which is good for the machine to make it unique and all of that. It's not that OpenAI is going to check for it, but for us, it's going to make it more organized. And then the extension. So that will give us this. And then the only thing that we need to do is that to create the file. So we do a join on the data files dir, and then we get it. We could have probably reused the one on top, but that's good enough. And then we're going to say if it does not exist, then we will force a reupload. So we're going to say let force reupload, and that will be our recreate or our bundle file, the one we just created, doesn't exist. And so the idea of this is when it's going to create the files over there, if we delete it and it recreate it, it will re-upload it. And so I'm using almost the files as a state. Again, that's just a strategy that typically I like to use files as states, but you don't have to go that way. But this one, if we remove the files, press save or refresh, cargo watch, and then it will recreate it and it will re-upload it without us saying anything. So that will, in a way, if it doesn't exist, it will override the recreate file. That's the strategy. And then we're going to rebundle if it exists or not to check. So the point here is to say, regardless of this flag, we're going to rebundle it. So that is what I was saying before. We're going to recreate it so as we can visually kind of debug it to see if it works. And then we can either delete it to be recreated, to be re-uploaded, or have a command that re-upload it if we want. And then finally, we are going to do the upload. And so for the upload, we are going to use the assistant upload file by name. We're giving our OAC, our client, the assistant ID, the bundle file, and the force re-upload that we computed over there. So that is what is important for that. Not for that, but for that. Now you can change your strategy and have it for that as well. Yeah. So that will do the magic over there. Press save to make sure everything compiles. This one needs to be imported. And then to keep track of our little counter over there, we say if uploaded, we add one. So we didn't really care about the file ID, but we care about the Boolean over there, which is returned by this guy here. And now we make sure to have that name uploaded. So now this body guy will respond with a number of files that has been uploaded. Okay, so now we're going to go there. And by the way, this one, I'm sorry I wasn't clear before, but this one is because I run my other code in parallel, my target code. So that's why I have that uploaded over there. But what we're going to do, to make sure that we're starting from scratch, is we're going to delete this guy. And because I did it manually, I'm going to have to delete those manually as well. So then we want to do that as well. So that is one thing we are going to do, because otherwise it's going to create a lot of noise, because if we delete an assistant, we need to make sure to delete the associated files. So let's do that. So right now we have the public function and it's actually in our assistant. And if we go to our CRUD over there, we go to our delete, and we need to make sure that we delete the files. So we don't really need to delete the association between the file and the assistant because we're deleting the assistant anyway, but we need to delete these files here because again, in OpenAI, you upload the files into your account, into the org, and then you attach it to the assistant. So we want to do some cleanup over there. So before deleting the assistant, we want to delete the associated file. And for that, we're going to do a for file ID in, and we have our cool get files hash map. So we're going to reuse this one. That will work very nice. So that will return the hash map. And now what we can do in the hash map is we can say into values, because it's a hash map of file ID by file name. So the file name is a key, the file ID is a value. So we say into values, and that will just give us a file ID. And now that we have the file ID, we can do, and we're going to keep the response over there, OA files, put the OA files over there, OAC, that files, and I'm going to do a delete, file ID, await, and I'm not going to do a question mark here, because if it fails, I'm okay with that. It means that it has already been deleted or whatever. And so I'm going to add a note, yeah, might be already deleted. That's okay for now. So we do res is okay. And so we're going to say if it's okay, we're going to println. So in this case, our strategy is to change a little bit. Rather to say that the file couldn't be deleted, we're going to say that the file has been deleted. And we're going to assume that if it's not, it's because it's okay, because it was already deleted. Okay, so I've done some, that's too much news. And OA files. Okay, so I think we're good on this one. And again, we're going to add probably a note here as well, just to be consistent. Note, no need to delete assistant files since we delete the assistant. Yeah, we are deleting the assistant here, should be fine. So that should clean up our mess. And by the way, just a note here, that when I was doing the coding and stuff, that is where I got a lot of bugs or forgot to delete it. And it was kind of a pain because then after I had a lot of files over there. And I wrote a little script to delete them because it was kind of a pain. So now we have all of this. And do I have my cargo watch running? Oh yeah. So now we have that and it uploaded the files, but we didn't upload the files yet. Yeah, we did not update that. So what we're going to do now is go back to our init, I think, and we're going to go to this one and we're going to have the upload file here. To do upload file. So far so good. Buddy, upload files. And here, like the other one, because one's in it, we're going to say force. Yeah? So we don't force a re-upload. We're just uploading if the file wasn't there. And then we press save, everything works. Aha, created the files, created only one. Oh yeah, because because we don't have the knowledge here. I'm going to add it later. And so it didn't crash, so that's cool. It didn't crash because the list was empty, so it was okay. And then he added this file where we put this kind of delimiter. This is a thing that needs to be tuned a little bit. It does matter how you give it, but so far it seems to work a little bit. And we'll need to but so far this seems to be working kind of okay. So make sure to not save by hand this one. So now we're going to start from scratch to make sure to delete any states we have. Also in the assistant, I deleted everything. And in the files, I also deleted everything to make sure that everything is start from scratch. So one thing also that I like to do, and this is hard to know if it's going to be useful or not, but first we're going to add a little paragraph here that say, first, please review the knowledge bundle. So that will be a file that we'll upload later. We'll have it there, and source bundle file before answering, and answer to the best of your ability. That will be one. And then we're going to have that. And this one, to be honest, I don't know if it helps. Sometimes it's hard with AI to know what it helps. I'm going to say when the user asks about the source module, check the source bundle file, and then I say everything is there. And then I say where the code is split with this file path things. It's not clear that that will help, but I'm putting that there. These kind of things need to be fine-tuned. The cool thing is we're going to add comments later. So we'll be able to refresh instruction, to refresh the knowledge base and all of that. And it will allow us to experiment faster. So that is the new instructions. And in fact, you know what? We're going to create the file over there. So this is a file, you can find it in the source. It's just some best practices over there, coding and stuff. It's a very short file. It's nothing much. Just to see that we have the files. So now we have our instructions. And so we can, well, let's go to main. So like this, we see, we do the loop. And today we support the chat. And then we'll add more there. And we're going to do our cargo run quiet. You don't have to put quiet. I like to have quiet. So that will compile the things. And then it will create the assistant, upload the instructions, bundle the file, upload the source code, bundle the file, upload the knowledge, and then we have the conversation created over there. So if we go to our body, we see the files, the 2 bundle files over there, the conversation, and that's it. So if we go back to our openai.com, we should see the 2 files at the org level. And if we go to the assistant, we should see everything we talk about, COBOL and blah, blah, blah. And then the 2 attached files over there. They're being nice with the end user. Okay, so, and we can start asking the questions. So the first one is going to be, what is the best language? And that is kind of a base question to make sure that it gets the instruction right. So we get the Rust. Second best, we get COBOL. So far, so good. And so now the trick is to say, does he have access to the source bundle? The thing I've noticed is sometimes you have to give it a little bit of time, because sometimes you say, I don't have the files somehow. So we're going to ask that. You say, do you have access to the source bundle files in the assistant? So it's not in the conversation, it's in the assistant. And then we're going to see what you say. Yes, okay, good. So the thing has been uploaded and everything. Sometimes it gets tricky. You might want to check by asking like that. That is a nice trick. And now we can do the question that we had at the beginning is, what is the difference between the AIS and Buddy module? Be concise, question mark. I like my question mark. And that it will get the data, it will determine what it needs, and then run it. Sometimes it goes faster, sometimes it does stuff. Okay, so what does it say? So basically not that it gives a different version of what we had in the intro, because sometimes the AI doesn't give the same answer. So far, that is not bad. It's what the AI. And this one is actually pretty good, managing conversation, which is a chat. So it doesn't mention OpenAI API like we have sometimes, but it's pretty good. And then we can say, what does the CLI module do? It takes some time, and then boom, the CLI module includes functions for handling prompt, icons, and text output. So far, so good. And it's pretty cool because our code was pretty descriptive. We didn't comment all the modules and everything, but it kind of get pretty cool. In fact, if we have our Copilot and we do a at workspace, I think now they have, and we're going to compare it. What does the CLI module do? Question mark. Interesting. Okay, the CLI module is loaded stuff, provide utility to function on command line. I mean, honestly, it's kind of the same. And if we ask a question, what is the difference between the AIS and Buddy module? Be concise. It's not clear if Copilot uses ChatGPT-4. I think it does, but kind of goes fast. But anyway, and that is also pretty cool. I like the formatting a little bit better on this one, but otherwise it's about the same thing. Okay, so that's pretty cool. We have our own things. The cool things now is we have this little prompt and we can do anything we want. And we can have bundled files, send it, and it doesn't have to be about Copilot and anything. So that is already very cool. One thing we're going to do to finish our command line is to complete all of the cool commands we have. So I'm going to do something like that, fill harm, press save for the reformat, and then we're going to fill up these guys, which is going to be trivial now. So the refresh all, super easy. We're going to do a init from dir, the whole thing, and then we're going to have a buddy load and create. And then important, in the init from dir, we are giving the true, so that will recreate it, and we'll delete the old one, the old assistant, and so on. And the same thing from the conversation. So that will do the work. Let's go down to say a little bit more. And now for refresh conversation, that is the easiest. We do the load or create conversation. So all the time we need to make sure we create a new conversation such as it doesn't get confused with the old one. And then the refresh instructions. So this one we have the upload instructions. And again, we refresh our conversation. And then the refresh files, we just upload our files, true, and then we do this. So now it's pretty cool because we have all this command line and we can refresh things with just the command. So if we go back to our console, we do a cargo run, quiet, it was already loaded, the files were already uploaded, so it's not needed. What is the best language? Second best. And the reason why I'm doing that is I'm going to go to my instructions and say that the second best is Lua. And I'm going to do a refresh instruction. The actual refresh instruction recreated the conversation. And now I say second best, boom, Lua. And that is pretty cool. And we can do the same thing with the files and so on. With the files, sometimes it takes a little bit of time before the assistant kind of knows that the file has been updated or everything. So you have to play with it a little bit to know. But that's it. That is a pretty cool little Rust AI buddy using the OpenAI Assistant API. So I will put it in the GitHub in the link below. And then I will probably also put it somewhere in the Rust 10x. So my plan is to go pretty big on AI and Rust for 2024. And right now it's our Rust web app blueprint, which will also have some agent and stuff inside. So that is production web app application. And then I'm going to create this Rust AI buddy over there. Okay, hope you liked it. Like and subscribe helps a lot. Comments, love them. Until next one, happy coding.